Welcome students, we are starting off with trigonometry. Now in trigonometry, first and foremost thing you will have to know is what is called a system of angle measurement. Now we follow the following system. We are to use either degrees or radians. So you would be popularly encountering these two terms, and they would be used depend upon the questions that we are facing. So have just in mind degrees and radians. Now the measure of one right angle, the measure of a right angle, in fact I have drawn a right triangle. So when I'm talking about the angle, I'm talking about the right angle that is made over here. Now that is equal to 90 degrees. Now 1 degree is equal to 60 minutes, and the representation is with the prime there, and 1 minute is equal to 60 seconds. Now this is in terms of trigonometry, so have that in mind. So you need not have to get confused with the time measurement. So this is purely in terms of trigonometry. Now let us talk about the relationship between degree measure and radian measure. Now radian measure is a SI unit, have that in mind. The connectivity between a degree and a radian measure is as follows. 180 degrees is equal to pi radians, have that in mind. Now if 180 degrees is equal to pi radians, what would be the radian equivalent for 90 degrees? Now this is dividing by 2, right? So this is going to be equal to pi divided by 2. Now if 90 degrees is equal to pi over 2 radians, then what would be 60 degrees? That would be pi over 3. So if 60 degrees is equal to pi over 3, what would be 45 degrees? So I'm going to come to 45 degree within a minute. Now let's move on to 30 degrees, right? If 60 degrees is equal to pi over 3, so what would be 30 degrees? So probably I will just represent 30 degrees over here. Now 30 degrees is nothing but pi divided by 6, that is 30 degrees. Now coming to 45 degrees, if I were to divide by 4, then I would get 45 degrees. So pi divided by 4 is equal to 45 degrees. So having got 180 degrees, 90 degrees, 60 degrees and 45 degrees and 30 degrees, it's time now we calculate 120 degrees. Now what is 120 degrees is equal to? Now there's a easier way to get the equivalent for 120 degrees. Now 120 degrees is nothing but 4 multiplied by 30 degrees. Now what exactly is 30 degrees? 30 degrees is nothing but pi divided by 6. Now 2 divides 4 2 times, 2 divides 6 3 times, so this is going to be 2 pi divided by 3. That's the value for 120 degrees. Now having got the value for 120 degrees, what is the radian measure for 150 degrees? Now 150 degrees is got when you multiply 30 degrees by 5. Of course, we know that 30 degrees is nothing but pi divided by 6. So the value for 150 degree is equal to 5 pi over 6. So these are some of the equivalent measures with regard to degrees and radians. So having obtained this, we will move on to the next topic. Now there are two important formulae we are expected to know. One is called the length of the arc, or it is also referred as arc length. Now the formula is as follows. Now just imagine that you have taken a pie, a piece from a circle, such that the angle is theta and this length is r, and you're expected to find L. This is the arc length. Now this is given by r times theta, and the theta that we will have to use here would be in radian measure. So have that in mind. So this is the most, or I should say a very important formula. L is equal to r times theta. Now there is another important formula which is called as area of a sector or the sector. So what are they talking about? They want to know what exactly is this area. So area of the sector is given by the formula 1 over 2 times theta times r squared. This is the second important formula we will have to know. So having learned these two formulae, let us apply them in problem solving. So let's do this question, students. We are given the angles of a quadrilateral or I should say the angles of a quadrilateral are given to be in AP. So AP stands for arithmetic progression. It is given that the greatest angle equals double the least angle. We are expected to express the least angle in radian measure. Okay. If you were to take a quadrilateral is nothing but a four-sided figure. It has got four angles, angle A, angle B, angle C, angle D. Now if you sum up all of these angles, it's going to be 360 degrees. But it is given that the angles are to be in AP. So first I'm going to say let alpha comma alpha positive D comma alpha positive 2D comma alpha positive 3D be the angles of the quadrilateral. Now this would mean alpha positive D positive alpha positive 2D positive alpha positive 3D is equal to 360, because we know the sum of the angles inside the quadrilateral is 360 degrees. Now adding alpha we get 4 alpha, and adding D 3D plus another 3D we would get 6D is equal to 360 degrees. Now dividing by 2 we get 2 times alpha positive 3 times D is equal to 180 degrees. Now in the question we are given, so what are we given? We are given that the largest angle is equal to twice the least angle. So if we were to move alpha to the other side, we would get 2 alpha negative alpha is equal to 3D, therefore 3D is equal to alpha. So if we were to take this as say 2, take this as 3, using 3 into we get, so what do we get? 3D is equal to alpha, so therefore I can rewrite 2 as 2 alpha. In place of 3D I'm going to substitute alpha is equal to 180. This is going to give me 3 times alpha is equal to 180, it would be 60 degrees, right? So this would mean alpha is equal to 60 degrees, but we are expected to give it in radian measure, so that would mean the solution is pi over 3. So that completes the answer to this question, students, and it is a good place for us to draw the red line. So students, let us do the following questions to get a greater insight into trigonometry. So we are given this question: consider a square of side 4 centimeter and that a man runs at a distance of 1 centimeter from the sides of the square. Find the distance. They are asking us the total distance covered by the man. So we are given a square. So this is the square and the sides of the square are given to be 4 centimeter, 4 centimeter, 4 centimeter, 4 centimeter. And a man is actually running, right? And the distance between the man and the square is 1 centimeter. So if the man is running along like this distance is 1 centimeter. So he runs like this. Naturally he has to take a bend, then he runs again. Over here he has to take a bend, then he runs again. Over here he has to take a bend, then he runs again. Over here he takes a bend. So there are actually 4 bends. Now if you were to actually make an observation, you will find that there is a quadrant being made over here. There are 4 quadrants. So if there is a circle, if you were to divide the circle by 2 lines, you will see that 4 quadrants make up the circle. So actually what the man is doing, apart from covering the distance along the sides of the square, he is also covering 1 full circle. So the formula would be total distance covered by the runner, covered by the running man, is equal to the distance covered for the square, that's 4 into 4, plus the circle, that's going to be 2 pi r. So this is going to be 4 times 4. So let me just write that as 4 square, positive 2 times pi. My r over here is 1 centimeter, right? This is 1 centimeter, 1 centimeter and 1 centimeter. So r is equal to 1 centimeter. So that would mean I now have 16 positive 2 times pi. But if I were to take the value of pi as 3.14, then this would be 16 positive 8 to 6, and if I were to add 16 with 6, that would give me 6 added with 6 is 12, carry 1 to 22.28 cm. So this is the total distance covered by the runner. So that is the solution. Of course, this is a simple question, but it's always good to start with questions of meager sum difficulty and then gradually scale up. So we'll move on to the next. Now next we will study the ratios of the right triangle. So we have a right triangle. This is 90 degrees. This is theta. Now the side opposite to theta is called as the opposite side. The side below the opposite side is called as the adjacent side, and the side above the adjacent side is called as the hypotenuse side. So foremost we will have sine theta. Sine theta is opposite side divided by hypotenuse side. Then we got cos theta. Cos theta is adjacent side divided by hypotenuse side. Then we got tan theta. Tan theta is opposite side divided by adjacent side. Now these are the ratios of the right triangle. Now we got the reciprocals for these things. So the first reciprocal is cosecant theta, then you got secant theta, then you got cot theta. Now cosecant theta is actually 1 over sine theta. So if you were to place the ratio for sine theta here, opposite side divided by hypotenuse side, when you flip this, this is going to be hypotenuse side divided by opposite side. And secant theta is 1 over cos theta, and similarly when you flip it, this is going to be hypotenuse side divided by adjacent side. And cot theta is 1 over tan theta, and when you flip it, it's going to be adjacent side divided by opposite side. Now for sine theta, cos theta, tan theta, you have a popular acronym. So they will represent sine theta as sine theta opposite by hypotenuse, and cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. So they call it as SOHCAHTOH, right? So probably if you want, you can have this acronym. It's all up to you, and there's no compulsion for you to use this. Okay, you can just remember the base, how exactly they are obtained, and that is sufficient enough. So we will move on, students. Now students, we will look into some trig identities. Now the most popular one, the first one that you will have to remember is sin square theta positive cos square theta is equal to 1. From here I can write sin square theta is 1 negative cos square theta, and cos square theta is 1 negative sin square theta. Now the next one, secant square theta negative tan square theta is equal to 1. From here we can write secant square theta is equal to 1 positive tan square theta, and also we can write tan square theta to be equal to secant square theta negative 1. The next one is cosecant square theta negative cot square theta is equal to 1, and cosecant square theta is equal to 1 positive cot square theta, and from here we can write cot square theta is equal to cosecant square theta negative 1. Right? Apart from that, you should also remember that secant theta is 1 over cos theta, cosecant theta is 1 over sin theta, and cot theta is 1 over tan theta. All of these things can easily be proved. Say for example, you can consider formula 7. So I'm going to show you how exactly it is proved. So cosecant square theta negative cot square theta is equal to 1. So what I wish to do is I will say consider the left hand side. So what is on the left hand side? cosecant square theta negative cot square theta. I'm going to replace cosecant square theta as 1 over sin square theta. Cot square theta is cos square theta over sin square theta. If I were to take LCM as sin square theta, I get 1 negative cos square theta. 1 negative cos square theta is sin square theta divided by sin square theta. They get cancelled, is equal to 1, which is equal to right hand side. So everything can be proved, and we will also be using cot theta to be as cos theta over sin theta and tan theta to be as sin theta over cos theta. So these are all some popular directions. So having given that, the next one that you will have to know is sin raised to the power of 4 theta positive cos raised to the power of 4 theta is equal to 1 negative 2 times sin square theta times cos square theta. This is a very popular identity which you will have to remember. Now how do I prove it? So let me just start out like this. Consider the left hand side, which is sin raised to the power of 4 theta positive cos raised to the power of 4 theta. I'm going to rewrite this as sin square theta positive cos square theta raised to the power of 2. If I expand this, I would get 2 times sin square theta cos square theta. So I can take that out. So this is going to be 2 times sin square theta cos square theta. But sin square theta added with cos square theta is 1. So this is going to be 1 negative 2 times sin square theta cos square theta. So this is a very important formula, and it is imperative that you take note of it. Now there is another important trigonometric identity which you will have to know, and that is sin raised to the power of 6 theta positive cos raised to the power of 6 theta is equal to 1 negative 3 times sin square theta cos square theta. Now I can give you the proof. So I'll start off like this. Consider the left hand side, which is sin raised to the power of 6 theta positive cos raised to the power of 6 theta. I'm going to rewrite this as sin square theta raised to the power of 3 positive cos square theta raised to the power of 3. Now there is a formula in algebra. We know that a cubed positive b cubed is a positive b times a squared negative ab positive b squared. So using this formula over here, this is nothing but a positive b. So sin square theta positive cos square theta times, and you have a squared. So a squared is going to be this raised to the power of 2. So that is going to be sin square theta. This is my a, right? But I have to raise it to the power of 2. So that would mean I got sin raised to the power of 4 theta negative ab. My a is sin square theta, my b is cos square theta. So this is going to be sin square theta cos square theta positive b squared. My b is cos square theta, squared is going to be cos raised to the power of 4 theta. So I can rewrite this. This is a formula. So I can rewrite this as sin square theta positive cos square theta is 1 times, I'm going to club these two together. This is going to be sin raised to the power of 4 theta positive cos raised to the power of 4 theta negative sin square theta cos square theta. But what is sin raised to the power of 4 theta positive cos raised to the power of 4 theta? This is the formula. You see that? Take this and substitute here. So this is going to be equal to 1 negative 2 times sin square theta cos square theta. Already there is sin square theta cos square theta. Sin square theta cos square theta can be added. So that would give me 1 negative 3 times sin square theta cos square theta. So this is a very important identity that you will have to remember. So what is the identity? The identity is sin raised to the power of 6 theta positive cos raised to the power of 6 theta is equal to 1 negative 3 times sin square theta cos square theta. Students, we have this question. given f of x suffix k is equal to 1 over k times sine raised to the power of k x positive cos raised to the power of k x, where x is element of real number and the value of k is greater than or equal to 1, and we are expected to find f suffix 4 of x negative f suffix 6 of x. What is the value? Now there are actually 4 choices given, right? Now this was a question asked in JEE and 2014. Now the 4 choices given were A 1 over 4, B 1 over 12, C 1 over 6, and D 1 over 3. Now you have to observe the following. Whenever you are asked questions in multiple choice and if you are run out of time, you can actually make the correct selection by merely observing the choices, right? So I hope you got what I'm trying to tell you. Now in this case, the choices given does not include x at all. So x and the solutions given are totally independent. It means you are given this function f of x suffix k is equal to 1 over k of sine raised to the power of k x positive cos raised to the power of kx. This is the function given. Now I can very well take x to be equal to 0 and find out the value of the function, because I can clearly find out if I know what is the value of the function at x is equal to 0. All I need to do is substitute the value for k for 4 and 6 and then find the difference. That's it. So if I were to take x is equal to 0, this is going to be f of 0 suffix k is equal to 1 over k. X is equal to 0, this perishes. X is equal to 0, this is going to be 1. Right? So I get 1 over k. So what is the meaning of this? This means f of 0 k is equal to 1 over k. So I can further rewrite this as f suffix k is equal to 1 over k. So which means f suffix 4 is equal to 1 over 4 and f suffix 6 is equal to 1 over 6, meaning f 4 minus f of 6 is equal to 1 over 4 negative 1 over 6. If I were to take the LCM as 6 and 4, 24, this is going to give me 6, this is going to give me 4, this is going to give me 2 over 24, which is nothing but 1 over 12, right? So this would be the choice. That's all. Of course, I have meticulously shown you all these steps, right? But you can actually obtain the solution in less than the time that I have depicted the steps. But alternatively, you can also go using the longer method, and that is exactly what I'm going to show you now. So let's do it by the longer method. So we have been given this function f of x suffix k is equal to 1 over k of sine raised to the power of k x positive cos raised to the power of k x, right? And we are expected to find f suffix 4 of x negative f suffix 6 of x. So that means from here the value of k is 4 and the value of k is equal to 6. So let me do that, taking the value of k is equal to 4. So when k is equal to 4, if I were to take this as 1, therefore 1 can be rewritten as f suffix 4 of x is equal to 1 over 4 of sine raised to the power of 4x positive cos raised to the power of 4 of x. And when k is equal to 6, 1 can be rewritten as, I'm placing it here, f suffix 6 of x is equal to 1 over 6 of sine raised to the power of 6x positive cos raised to the power of 6x. Now we are expected to find the difference, right? So minus minus. So what would that be? This is nothing but f suffix 4 of x negative f suffix 6 of x is equal to 1 over 4 of sine raised to the power of 4x positive cos raised to the power of 4x negative 1 over 6 times sine raised to the power of 6x positive cos raised to the power of 6x. But we know a formula. So what is the formula we know? This is actually 1 negative 2 times sine squared x cos squared x negative 1 over 6 times. This is nothing but 1 negative 3 times sine squared x cos squared x. Okay, so I can simplify this. So this is equal to 1 over 4 negative 1 over 2 times sine squared x cos squared x negative 1 over 6 positive 3 divided 6 2 times, so 1 over 2 sine squared x cos squared x. Now positive 1 over 2 sine squared x cos squared x negative 1 over 2 sine squared x cos squared x. Both of them get cancelled. You get 1 over 4 negative 1 over 6, which would give me same value 1 over 12. So this is another way which we have seen. So having got that, it's purely at your discretion to apply which method you are comfortable with. Students, let's go ahead and do the next question. We are given this question: for any theta element of pi over 4 comma pi over 2, we are expected to find the value of the following expression. The expression 3 times of sine theta negative cos theta raised to the power of 4 positive 6 times of sine theta positive cos theta raised to the power of 2 positive 4 times sine raised to the power of 6 theta is equal to what? Now this occurred in JEE 2019 and you have 4 choices. So choice A, is it 13 negative 4 times cos squared theta positive 6 sine squared theta cos squared theta, or is it 13 negative 4 times cos raised to the power of 6 theta, or is it 13 negative 4 times cos squared theta positive 6 times cos raised to the power of 4 theta, and D is 13 negative 4 times cos raised to the power of 4 theta positive 2 times sine squared theta cos squared theta. Now if you do not have time, there is no time at all, and you are expected to make a choice, which of these would be your selection? Come on, place that in the comment box. Now you should be true to yourself, right? You are given 4 choices, A, B, C, D. You are expected to pick just only one. So which one would you choose? Now if you don't have time at all, now clearly what you need to do is you have to make an observation. Just see the choices. The first choice has got cos squared theta, sin squared theta, cos squared theta. The choice number C has got cos squared theta and cos raised to the power of 4 theta. And then you got cos raised to the power of 4 theta and 2 times sin squared theta, cos squared theta. So A and D are not going to be the selective choices at all, because you can clearly see that A and B are actually one and the same, except for the factored value being different. Now coming to the point B and C. Now if you were to see, all of these terms I've got 1, 2, 3, 1, 2, 3, 1, 2, 3. The only term that isn't having the third term is B. So this would be the likely choice. Of course, I'm not asking or I'm not telling you to resort this way. In the event of not having time, if you don't have time, then you can always adopt, right, mathematical intuition, and that is accepted science. So that is actually trial and error. The very concept of trial and error is based on what? It is based on your ability to guess and check. So this is actually a branch, guess and check. Of course, we can't be guessing and checking. This will give us a rough idea. So I'm just giving you a tip. So having mentioned this, what I wish to tell you is, in this particular question, though I'm going to give you the exact steps and the algorithm, how exactly we're going to achieve it, clearly I know that there should be cosine involved in the solution. So having known that, let's proceed in going step by step and then finally achieving our means. So students, what I will do is I will write the given question, given expression, which is actually 3 times of, I'm not going to use write sine theta as sine theta. I'm going to use the representation as S. That would save us some time. So this is given 3 times. S stands for sine theta and C stands for cos theta. In this case, this is being given raised to the power of 4, positive 6 times of S, positive C raised to the power of 2, positive 4 times S raised to the power of 6. This is given. So let us simplify this and find out what exactly this expression is taking us to. So I can rewrite this as 3 times of S negative C. I want to raise this to the power of 2, and then I'll raise this again to the power of 2. Positive 6 times. If I were to expand this, I would get S squared positive C squared positive 2 times S into C, positive 4 times S raised to the power of 6. So this can be further rewritten as 3 times of, I expand this, I get S squared positive C squared negative 2 times S into C. This is raised to the power of 2, positive 6 times S squared added with C squared, sine squared added with cos squared will give me 1, positive 2 times S into C, positive 4 times of S raised to the power of 6. Now similarly these two can be added. So this is going to give me 3 times of 1 negative 2 times S into C raised to the power of 2, positive 6 times 1 positive 2 times SC, positive 4 times S raised to the power of 6. So this is further rewritten as, I have to expand this, I get 1 positive 4 times S squared C squared negative 4 times S into C, positive 6 times of 1 positive 2 times S into C, positive 4 times S raised to the power of 6. Now this is rewritten as 3 positive 3 times 4 12 S squared C squared negative 3 times 4 12 S into C, positive 6 positive 12 times S into C, positive 4 times S squared negative 12 times SC, positive 12 times SC can be cancelled. 3 added with 6 would give me 9, followed by 12 times S squared C squared. This is actually 4 times S raised to the power of 6, right? So followed by 4 times S raised to the power of 6, right? So now what I wish to do is I would like to split this as follows. So 9 positive 12 times S, the sine square theta is nothing but 1 minus cos square theta, right? So 1 minus c square theta times c square theta, positive 4 times of, now S raised to the power of 6. Now we will have to split this in such a fashion that we are having some level of cos in it, right? Because clearly, as I mentioned to you, we need to have the cos. So I would have to get that. Now the only possibility that we could get it is that we will have to fragment the sine component. So what I want to do is I would like to write this as S squared raised to the power of 3, right? It's fair enough. But this is nothing but sine squared. Now sine squared theta is, let me write the formula. Sine squared theta is actually 1 negative cos squared theta. So in this case, I'm going to use S squared is equal to 1 negative c squared, right? So if I were to use that over here, this is going to give me 9 positive 12 times, I'm not going to distribute it as yet, 1 negative c squared of c squared positive 4 times of 1 negative c squared raised to the power of 3. Now this is nothing but a minus b raised to the power of 3, which is nothing but a cubed negative 3 times a squared b positive 3ab squared negative b cubed. So if I were to use the formula over here, this is going to give me 9 positive 12 times 1 negative c squared of c squared positive 4 times of 1 negative 3 times c squared positive 3 times c raised to the power of 4 negative, this one is actually b cubed, so this is actually c raised to the power of 6, right, because of the fact you got b cubed there. So now let me distribute the quantity. So this is going to be 9 positive 12 times c squared and negative 12 times c squared is going to be 12 times c raised to the power of 4 positive 4 negative 12 times c squared positive 12 times c raised to the power of 4 negative 4 times c raised to the power of 6. C raised to the power of 6 is there. So negative 12 times c squared positive 12 times c squared can be cancelled. Negative 12 times c raised to the power of 4 and positive 12 times c raised to the power of 4 can be cancelled. We got 9 added with 4, that is going to be 13, followed by negative 4 times c raised to the power of 6, which can be rewritten as 13 negative 4 times cos raised to the power of 6 times theta. So this is the solution that we have obtained. So as I mentioned to you students, this is the complete steps for this question, and we will move on to the next one. Students, let's do the next question. Now this question is featured in JEE Advanced 2009. So the question is, if sine raised to the power of 4x divided by 2 positive cos raised to the power of 4x divided by 3 is equal to 1 over 5, then we have given the following choices. Choice number A is tan squared x is equal to 2 over 3, and then choice number B is tan squared x is equal to 1 over 3, and C is sine raised to the power of 8x divided by 8 positive cos raised to the power of 8x divided by 27 is equal to 1 over 25, and D is sine raised to the power of 8x divided by 8 positive cos raised to the power of 8x divided by 27 is equal to 2 over 125. So we got 4 choices and we are expected to zero in the correct choice. So let me just work the solution out. So we are given, consider sine raised to the power of 4x divided by 2 positive cos raised to the power of 4x divided by 3 is equal to 1 over 5. Now what I wish to do is, I would like to actually write this as s raised to the power of 4 divided by 2 positive c raised to the power of 4 divided by 3 is equal to 1 over 5. Now if I were to take the LCM as 6, I would get 3 times s raised to the power of 4 positive 2 times c raised to the power of 4 is equal to 1 over 5. Now let me use the space here. So from here, this would mean 3 times s raised to the power of 4 positive 2 times c raised to the power of 4 is equal to 6 over 5. So this is what I've got. Now what I wish to do is, I would like to convert all the cosines into sine. So this is going to be 3 times s raised to the power of 4 positive 2 times. Now we know that cos square theta is 1 negative sine square theta. So if I were to write it as c, this is going to be c squared is equal to 1 negative s squared. So if I were to write this as c squared raised to the power of 2, then this would be further rewritten as 3 times s raised to the power of 4 positive 2 times of, my c is 1 negative s squared, that has to be raised to the power of 2 is equal to 6 over 5. So let me use this space over here. So I've got 3 times s raised to the power of 4 positive, I expand this, so this will give me 1 negative 2 times s squared positive s raised to the power of 4 is equal to 6 over 5. You distribute this, this is going to be 3 times s raised to the power of 4 positive 2 negative 4 times s squared positive 2 times s raised to the power of 4 is equal to 6 over 5. Now I can add this with this, and that would give me 5 times s raised to the power of 4 and then positive 2 there, okay, and then 4 times s squared is equal to 6 over 5. Now if I were to cross multiply with 5, I would get 25 s raised to the power of 4 negative 20 s squared positive 10 is equal to 6. This is what I would get. Now if I were to bring the 6 to this side, this is going to be 25 s raised to the power of 4 negative 20 s squared positive 10 negative 6 is equal to 0, which, let me use this part of the page. So this is nothing but 25 s raised to the power of 4 negative 20 s squared positive 4 is equal to 0. Now if I were to write this as 5 s squared raised to the power of 2 negative 20 s squared, I want to write 20 s squared as, probably let me just write this off. So this is going to be 2 raised to the power of 2 is equal to 0. So this can be rewritten as 2 times 5 times s times 2, right? So what do you see here? You see a squared negative 2ab positive b squared. So can I write this as 5 times s squared negative 2 raised to the power of 2 is equal to 0, because when you have to expand this, you get 5s squared raised to the power of 2 this term, 2 squared this term, and then 2 times ab. So that's going to be 2 times 5s squared, right? So this would be a s squared here, right? So this, because of the presence of s squared here. So 2 times of 5s squared times 2. So 2 times 5 is 10, 10 times 2 is 20 with a negative sign. So this is absolutely fine. So from here, what do you get? This is a perfect square. So 5 times s squared negative 2 is equal to 0. So let me write this down like this. 5 times sine squared theta is equal to 2. So sine squared theta is equal to 2 over 5. Now if sine squared theta is 2 over 5, I can write this as 1 negative cos squared theta is equal to 2 over 5. Let me use this part of the page. So 1 negative 2 over 5 is equal to cos squared theta. So 5 negative 2 divided by 5 is equal to cos squared theta. So therefore cos squared theta is equal to 3 over 5. So sine squared is this and cos squared is this. So from here, if we were to, let me use this part of the page. So therefore if I were to write tan squared theta, of course it's actually x, so we should have used x, but I've used theta. Anyway, let me just change it to x, 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 and x. So I need to get tan squared theta. So if I were to divide sine squared x over cos squared x, so what happens here? Sine squared x. Therefore sine squared x divided by cos squared x is equal to 2 divided by 5 divided by 3 over 5, which is going to give me 2 over 3, right? Because 5 gets cancelled, giving you 2 over 3. So but what is this? This is tan squared, right? So this is tan squared x is equal to sine squared x over cos squared x. The value is 2 over 3, and this is the choice. Okay. Now having obtained the choice, now since it is a multiple choice question, there might be a possibility where the available choices includes two other preferred choices, right? In that case, we would also be required to find if there are any other choices available. Now, clearly we have found out that A is a choice, right? Sometimes you might be given something like this, say A and B, or like this, A and C, right? But clearly we know that A is one of the choices. So in that case, we will have to find the other choice. Now, clearly A and B is not possible, just for the sake of illustration purposes. So the other possibility is A and C. Now, just a small correction. This should be 1 over 125, right? Now, I'm placing here 1 over 125 so that you will be able to better appreciate it, why this choice is present. So now the condition comes, what if I were to find out if one of this is a choice also? So in this case, what I wish to do is I would like to consider C or D, because you can clearly see that both C and D have got 8 in the denominators, 27 in the denominator. You can clearly see. So out of these two, definitely one would be a preferred choice, or one would be the choice that would really result as a probable solution. Now we can only make, what should I say, insugination unless or until we have a very verifiable method. So that is exactly what I'm going to show you here. Now let me use this space here. The space is limited, so I will try to squeeze it because I don't want to go to the next page. If I were to go to the next page, I would lose the consistent continuity. So let me just consider this one, the left hand side. So I'm going to write this as S. This is actually S raised to the power of 8, right? So I'm going to write it as S squared raised to the power of 4. Why am I writing as S squared? Because I know the value for S squared. That is the simplest reason. So S squared raised to the power of 4 divided by 8, positive C squared raised to the power of 4 divided by 27, which is equal to my S squared value. We have already got the value for S squared, right? So let me show you the value. This is 2 over 5 is the value. 2 over 5 and 3 over 5. So I'm going to substitute 2 over 5 raised to the power of 4 divided by 8 positive, and the other one is 3 over 5 raised to the power of 4 divided by 27. Now this is equal to 2 raised to the power of 4. 2 2s are 4, 4 times 2 is 8, 8 times 2 is 16 divided by 5 raised to the power of 4 times, I can push this 8 over here, right? Positive 3 raised to the power of 4. 3 3s are 9, 9 3s are 27. So it's going to be 3 times 27, because I want to get rid of the 27, divided by 5 raised to the power of 4 times 27. So clearly this 27 can be cancelled. 8 divides 16 2 times. So this is equal to 2 divided by 5 raised to the power of 4 positive 3 divided by 5 raised to the power of 4. I take the LCM as 5 raised to the power of 4. I have a 2 positive 3, which is equal to 5 over 5 raised to the power of 4, which is equal to 1 over 5 raised to the power of 3, which is equal to 1 over 125, which is this choice, right? So this is the way you have to work it out. So having mentioned this, we'll move on to the next one. Students, next we will have to know what is called as the cast rule. You can either call it as cast rule, they will also mention it as ASTC rule, right? And then I will also explain to you the reduction formula. So it's a very important topic, and it's, I would say, it's the art of trigonometry. When I say art, I meant this art, right? The core concept in trigonometry. Now, if you were to take the quadrant, now we always refer trigonometry relativity with quadrant. Always we talk about the angles with reference to the fourth quadrant. So this is the first quadrant. So when I say quadrant, you spell it like this, Quadrant, the quadrant. So this is one quadrant. So this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Of course, the angles, the measure is from 0 to 180 degrees, and then it goes up to here 270 degree and ends here at 360 degrees. In the first quadrant, we say A. So that means all ratios are positive. All ratios are positive. So what does it mean all ratios are positive? It means sine is positive, cos is positive, and tan is positive, and the reciprocals. The reciprocal of sine is cosecant theta, it's positive. Reciprocal of cos theta is secant theta, it's positive. Reciprocal of tan theta, that is also positive in the first quadrant. Now in the second quadrant, only sine is positive. Only sine is positive, and its reciprocal. The reciprocal for sine is cosecant theta, right? And cosecant theta is positive. So only these two are positive in the second quadrant. In the third quadrant, tan is positive and its reciprocal, that's cot. Only these two are positive. In the fourth quadrant, cos alone is positive and its reciprocal, which is secant theta, that is positive. So when we say exactly cast, so we talk about like the C-A-S-T, that's what we say. So have that in mind, and with some problems you will be able to gain a mastery on that. Now, having mentioned the cast rule, now let me mention the reduction formula. Now there are two important formulas which you will have to know, and they are very powerful. That is, if you were to be asked to find sine of some constant multiple of pi plus theta, the outcome will always be either plus or minus sine theta. There wouldn't be any change in this. The only thing that will change is the sign, either a plus or a minus, but sine will always be occurring with the angle. So this is one. The next formula is, if you were to be asked sine of some constant times pi over 2 positive theta, then the outcome would be plus or minus cos theta. So in this case, cos will be there no matter what, because of the fact that you got k times pi over 2. But the only change would be either a plus or a minus. So using this, we would be doing problems, and as I always mention, the best way to understand any concept is problem solving. So we will continue this lecture in the following class, students. Until then, have a nice night. Students, we would be finding now the value of the following. Now the first question is, what is the value of sine of pi negative theta? Now clearly in the formula I have given you, sine of k times pi positive theta would be equal to plus or minus sine theta, depending upon the quadrant that we have. So in this case, the problem is sine of pi negative theta. Now if we were to draw the quadrant, we know all ratios are possible. Sine alone is positive here, and tan is positive here, and cos is positive. So when I say cos is positive, it means cos and its reciprocals are positive. Sine and its reciprocals are positive. Tan and its reciprocals are positive. So this is going to be 0, this is 90, this is 180, this is 270, and this is 360 degrees. Now pi negative theta, now this is pi. Now whenever you have a negative sign, you are basically talking about a coordinate or a point between 180 and 90. So remember, always negative sign means you move up, positive sign you move down. So Since it is in the second quadrant, sine is always positive here. So this is going to be, I know that it's going to be sine theta because of the formula I've given you, and the sine is going to be positive. So that is the solution for the first question. Now question number 2. Let us see what would be the situation if they have given us sine of pi over 2 negative theta. I've clearly given you the formula. Sine of k times pi over 2 positive theta is equal to plus or minus cos theta. So 90 degree is over here. I already told you if it is negative, it will move in this direction. So that means we are looking at a quantity which is in the first quadrant. First quadrant means all ratios are positive. So the sign is going to be positive. But apparently we need to have a cos theta there because of the formula. So that is the solution for the second question. So let's go and do the third question. Third question wants us tan of pi positive theta. Now remember, the formula which I've given you for sine will also go for tan. Okay, so have that in mind. So in this case we would be looking at, in this case we're getting sine here, so we would be getting tan here, tan theta. The main point is it a positive sign or a negative sign? Is it a plus or a minus? So as I mentioned to you, 180 is over here between the second quadrant and the third quadrant, and anything positive will be located over here. So this would mean tan is always positive in this case, so it's going to be plus or positive tan theta, depending upon what you would like to say, whether it's positive tan theta or plus tan theta. Now coming to the next question, question number 4. Let's see what happens to secant of 3 pi over 2 positive theta. Now what is secant theta? Now secant theta is nothing but 1 over cos theta. So it's a reciprocal of cos. Secant theta is a reciprocal of cos. Now we have secant of 3 pi over 2 positive theta. So the question is, what would be the output? Now when it is sine, please watch here, if it is sine k pi over 2 positive theta means we are getting cos. On the contrary, if it is cos, then we would get a sine. So in this case it is secant, so we would get a cosecant. Okay, so 3 pi over 2, 3 pi over 2 is nothing but 3 multiplied with 90, which is nothing but 270 degrees. So the position is over here, 270 degrees is over here. Positive sign, as I mentioned to you, positive means it will be located on this side. So over here cosine is actually a positive ratio. Cosine along with this reciprocal, which is secant, will produce a positive ratio. So in this case we will have a positive sign. Okay, so moving on, let's do the next question. The next question is cot of 11 pi over 2 negative theta. Now what is this? Now as I mentioned to you, when we add tan, the outcome would be cot, but in this case we got cot because of the presence of pi over 2, so the outcome is going to be tan. Now the question is it a positive tan theta or a negative tan theta? That is the decision that we will have to take. So how do we take it? Now first foremost, let us find out what is 11 pi over 2. 11 pi over 2 is nothing but 990. Whenever an angle that we get is greater than 360 degrees, we have to keep subtracting 360 degrees from this angle until we get a value which is lesser than 360. So in this case you got 990. Let me subtract 360 degrees. So this is going to be 0, this is going to be 3, and from 9 I have to take away 3, I will get 6. So now I got 630 degrees. Again it's greater than 360 degrees. So subtract 360 degrees from this. So this is going to be 0. I borrow 1, 13. From 13 I take away 6, that will be 7. This is 5. From 5 I take away 3, it's going to be 2. So 270 degrees is less than 360 degrees. So we stop here. So where is 270 degree? It is between the third quadrant and the fourth quadrant. So this is the point that we are looking for. Now the question is, we have negative. So negative means we go towards the left. Okay, so this is the location that we are looking for. Now in this case, tan is positive and its reciprocal is positive. That is, cot is also positive. So we have a positive sign. Simple, isn't it? So finally, let us talk about secant of 7 pi positive theta. Now what is this 7 pi? 7 pi is nothing but 7 times 180. What is that equal to? 0. 7 times 8, 7 8s are 56, 5, and 7 1s are 7, positive. We need to add 5, so we are getting 1260. So we have to subtract 360. So let's see what happens. So as I mentioned before, if an angle is greater than 360, you keep subtracting 360 from the outcome. So let me do that. 360, I'm subtracting, I get 0, 0. This is going to be 900. That's 9. So again, it's greater than 360. I'm going to subtract 360 now. 0, 10, and 4. This is 8. I get 5. So 540. Again, I subtract 360. So 0. This is going to be 8, 4, 180. So 180 degrees. So 180 degree actually lies between the quadrant 2 and quadrant 3. So this is the point that we are looking for. Now positive sign means it will go down. In this case only tan and its reciprocal cot is positive. So we will place here negative secant theta. Students, let's do this question. We are asked to find the value, and this is the expression that's been given. Tan pi over 11 positive tan 2 pi over 11 positive tan 4 pi over 11 positive tan 7 pi over 11 positive tan 9 pi over 11 positive tan 10 pi over 11. So this is the question that is being given to us. Now let me rewrite this as follows. This is, I'm not going to do anything to tan pi over 11, and I will also retain tan 2 pi over 11, and I will also retain tan 4 pi over 11. Now tan 7 pi over 11, I would like to write it as tan pi negative 4 pi over 11. 11 times pi gives me 11 pi, minus 4 pi divided by 11 would be 7 pi over 11. Positive, I want to write 9 pi over 11, tan 9 pi over 11 as tan pi negative 2 pi over 11. So this, if you were to simplify, this is going to be 11 pi minus 2 pi divided by 11. So that's going to be 9 pi over 11. So we would be getting this. So followed by positive tan pi negative, I would be having this as pi over 11, because 11 times pi gives me 11 pi minus pi. That's going to be 10 pi divided by 11. So this is what we would get. Now having obtained this, now we know that tan of pi negative theta, what is that? Tan of pi negative theta, this is going to give me tan theta, of course, that is there, but we need to decide on the sign, is it plus or minus. Now go to the quadrant. First quadrant, all ratios possible. Second quadrant, sine alone is possible. Third quadrant, tan is possible. I mean, when I say possible, it means positive, right? So that's exactly what I'm meaning. So all ratios are positive. Sine alone is positive, tan alone is positive, cosine alone is positive with the fourth quadrant. Now, as I mentioned to you, when you talk about 180 is over here between the second and the third quadrant. And when you are required to subtract something, I told you, you should go above. So over here, you go up. If it is positive, you go down. So if you are here, you are expected to take a minus like this, you will have to go to the left, and positive sign will always lead you to the right. So I have already mentioned this. So in this case it's 180 negative. Over here negative means it lands up in the second quadrant, and only sign is positive here. So tan is not positive. So this would mean you would get a negative. We would be using this formula. So by this formula, what would happen? Let me rewrite that. The expression. So this expression would now be rewritten as, so let me have it like this: tan pi over 11 positive tan 2 pi over 11 positive tan 4 pi over 11. Now tan of pi negative 4 pi over 11. So this is going to be negative of the angle, right? So it's going to be negative tan this angle. That's going to be 4 pi over 11. So positive, this is tan of pi negative 2 pi over 11. So this is going to be negative, right? So it's going to be negative of tan 2 pi over 11. So it's already positive here. Positive times negative will become negative. So finally, tan of pi negative theta. So that's going to be negative tan theta. So this is going to be negative tan of pi over 11. So clearly positive pi over 11, negative pi over 11 can be cancelled. This is going to be negative tan 2 pi over 11 and positive tan 2 pi over 11. They can also be cancelled. This is tan 4 pi over 11 and followed by negative tan 4 pi over 11. So they can be cancelled. So giving me the output of 0. So that is the solution for this beautiful question. So we can move on to the next question. So next, students, we will have to deal with negative angles. What would be the situation when theta is negative? So when I talk about negative angles, we are talking about the trigonometric ratio of sine, cos and tan. So sine of a negative angle, that's negative theta, is going to be negative sine theta. A very important outcome. And cos of negative theta is equal to cos theta. And similarly, you got tan of negative theta is equal to negative tan theta. So the reciprocal of sine is cosecant. Similarly, cosecant of negative theta is equal to negative cosecant theta, and reciprocal of cos is secant. So secant of negative theta is equal to secant theta. Reciprocal of tan is cot. So cot of negative theta is equal to negative cot theta. This is called even function. And this along with this are called as odd function. Okay, so have that in mind, even function and odd function. Let's do this question, students. We are expected to find the value of sine for 20 degrees times cos 390 degrees positive cos 300 degrees times sine of negative 330 degrees. Now, since sine of negative theta is negative sine theta, I would be using that over here and rewriting this entire component as, this is sine 420, right? So this is going to be sine of 420 cos of 390 negative cos 300 times sine 330. This is what I've got. Now let me evaluate first sine 420. Now I would like to write sine 420 as sine of 450 negative 30. Now I've told you already, if you are given an angle which is greater than 360, this is clearly greater than 360, subtract 360 from this. So 450 negative 360 would give me 90 degrees. So that means we are looking at angle which is actually first and the second quadrant, right? So 90 degrees over here. So this is what we are looking at. Now I can actually rewrite this as sine of 5 times pi over 2, because this is going to give me 90. 90 times 5 is going to be 450 negative. This is actually, let me just take it as theta. So from the formula which we have studied earlier, this is going to be equal to cos, right? So this is cos theta. The only thing is that we are worried about the sign, whether it's positive sign or negative sign, because it's 90, so it's over here, so that means all ratios are positive, so there's going to be positive cos theta. So according to this, of course we don't have to mention this is for your understanding. So what I'm going to do is I'm going to rewrite this as sine of 5 times pi over 2 negative 30 degrees, which is nothing but cos of 30 degrees, and the sign is a positive sign, sign being negative, so it would be on the first quadrant over here. So that's why I'm just taking it as positive. In fact it is positive. But what is cos 30? Cos 30 is going to be root of 3 divided by 2. This is the value for sine of 420. So we have got that value, and let me place it in a box. Now next comes cos of 390 degrees. Now what is cos of 390 degrees? I can write cos of 390 degree as cos of 360 degree positive 30 degrees, right? Now what is this? This is nothing but cos of 2 times pi. This is k times pi positive theta. Now this is going to be equal to cos theta. So let me write the outcome here. So it's going to be cos of 2 times pi positive 30 degrees, which is going to be positive cos 30, which is going to be root of 3 over 2. So we've got the value for cos. So in fact this is actually cos of 390 degrees. So this is the value for cos 390. So having obtained cos 390, let us obtain what is cos 300 degrees. Now cos 300 degrees is nothing but, I can rewrite this as cos of 360 degree negative 60 degrees, right? Now this is nothing but cos of 2 times pi negative theta, right? So in fact it's I can just, let me just write the formula out. So this is going to be cos of theta, but I'm not sure if it is going to be plus or minus, so let me check that out. So 360 degrees over here, so if it is minus, it is going to come down here, whereas cosine is positive, so it's going to be positive sign there. So that would mean this is equal to cos of 2 times pi negative 60, which is equal to positive cos of 60, which is nothing but 1 over 2. So that is the value for cos 300 degrees. So now comes sine. We need to find sine 330 degrees. Now sine 330 degree is nothing but sine of 360 degrees negative 30 degree, which is nothing but sine of 2 times pi negative 30. Now of course we all know this is going to be sine 30, but the question is it positive or negative? So 360 is here. Now if I were to take a negative of this, okay, it is going to come down here. Only cosine is positive, so it's going to be negative sine 30, which is nothing but negative 1 over 2. So if I were to take the values and substitute, so therefore this would imply, let me write down the question, sine of 420 times cos of 390 negative cos 300 times sine 330 is equal to sine 420 is root 3 over 2 times sine cosine 390. Cosine 390 is root of 3 over 2 negative cos 300. Cos 300 is 1 over 2 times sine 330. Sine 330 is negative 1 over 2. So this is going to give me root 3 times root 3 gives me 3. 2 times 2 gives me 2 squared. 1 times 1 with a negative sign gives me positive. It's going to be 1. 2 times 2 is going to be 2 squared. I take the LCM as 4. This is going to be 3 positive 1, which is nothing but 4 divided by 4, which is equal to 1. So this is a beautiful question and it requires some working. So I hope you enjoyed this question, students. We'll move on to the next one. Students, let's do this question. We are expected to evaluate the following expression, which is 3 times of sine raised to the power of 4 of 3 pi over 2 negative alpha positive sine raised to the power of 4 of 3 pi positive alpha negative 2 times of sine raised to the power of 6 of pi over 2 positive alpha positive sine raised to the power of 6 of 5 pi negative alpha. Right, now this is going to be cos, and because of even power, plus or minus, it's not going to matter. So this is going to be cos raised to the power of 4 alpha. Positive, this is going to be sine. As I mentioned to you, the degree is 4. So this would produce as sine raised to the power of 4 times alpha. Negative 2 times, this would produce as cos raised to the power of 6 times alpha. This would produce as positive sine raised to the power of 6 times alpha. So this is what we've got. Now I will be using the identity. What is the identity? We know that since we know that sine raised to the power of 4 alpha positive cos raised to the power of 4 alpha is equal to 1 negative 2 times sine squared alpha times cos squared alpha. Also we know that sine raised to the power of 6 alpha positive cos raised to the power of 6 alpha is equal to 1 negative 3 times sine squared alpha times cos squared alpha. These two identities we proved. So with the help of the identity, I am going to rewrite this as 3 times of 1 negative 2 times sine squared alpha times cos squared alpha negative 2 times 1 negative 3 times sine squared alpha times cos squared alpha. Now this implies you would now have 3 negative 3 times 2 is 6. So let me write that 6 sine squared alpha cos squared alpha negative 2 times negative negative positive 6 times sine squared alpha times cos squared alpha. Positive 6 times sine squared alpha times cos squared alpha can be cancelled with 6 times sine squared alpha cos squared alpha with a negative sign. 3 added with negative 2 would give me 1. So this is the solution for this beautiful question. By the way, this question was asked in JEE mains. We'll move on to the next question, students. Students, now we are going to look into compound angles. And these are some of the important identities you will have to know. So to start with, sine of A positive B is equal to sine A cos B positive cos A sine B. Identity 2, sine of A negative B is equal to sine A cos B negative cos A sine B. Identity 3, cos of A positive B is equal to cos A cos B negative sine A sine B. And finally, cos of A negative B is equal to cos A cos B positive sine A sine B. So when we talk about compound angles, these are the compound angle formula connected with sine and cosine. So having mentioned this, let's move on, students. Now, having given you the compound angle formula for sine and cosine, now let me give you the compound angle formula involving tan and cot. So let me write down compound angle identities, in fact. I call them as identities involving tan and cotan. So the first and foremost important one is tan of A positive B is equal to tan A positive tan B over 1 negative tan A tan B. Formula number 2, tan of A negative B is equal to tan A negative tan B divided by 1 positive tan A tan B. So this is for tan. Now let me write the equivalent for cotan, that's cot. So cot of A positive B is equal to cot A cot B negative 1 divided by cot A positive cot B, and cot of A negative B is equal to cot A cot B positive 1 divided by cot. In this case it would have to have a reversal here. So this is A minus B, so we won't have it as cot A negative cot B, we'll have it as cot B negative cot A. So that is how it would be obtained as. Now we can verify all of this, right? It's possible to verify each and every formula, and that wouldn't be a difficult task. So having given this compound angle formula, I would suggest that you practice them thoroughly so that it becomes second nature for you. Let me just show you the proof of one of these formulas. So I would like to show you how exactly cot of A negative B is equal to cot A cot B positive 1 divided by cot B negative cot A. Now what I wish to do is I would like to consider the right hand side. So what do we have in the right hand side? We got cot A cot B positive 1 divided by cot B negative cot A. Now I can rewrite cot A as cos A over sin A times cot B as cos B over sin B positive 1 divided by cot B as cos B divided by sin B negative cot A as cos A divided by sin A. Now if I were to take the LCM for the numerator, this is going to be sin A sin B, and I would have cos A cos B positive sin A sin B, right? This entire thing is divided by, if I were to take the LCM as sin A sin B, I would get cos B sin A negative cos A sin B. Now this has to be divided by sin B sin A. Clearly you can see sin A sin B sin B sin A, they can be cancelled, giving us cos A cos B positive sin A sin B divided by, I can write this as, okay, let me write it as cos B sin A negative cos A sin B. So this is what I've got. Now cos A cos B, and I've got sin A sin B. So this is going to be cos of A minus B divided by, now I got sine A cos B negative sine B cos A. So what is this? This is nothing but sine of A minus B, right? But what is cos over sine? Cos over sine is nothing but cot. And what do we have? We got A minus B. And what is that? That is nothing but equal to the left hand side. You see that? So hence proved. So that's the end of solution. So having given you all this, there is one more important formula you will have to know. So this is 1, 2, 3 and 4. There is a fifth one which is very important, and that is tan of pi over 4 plus or minus a, which is equal to 1 plus or minus tan a divided by 1 minus or plus tan a. Now this result can be easily proved from tan of a plus b formula, right? So I can just show you this. So if we were to ask tan of pi over 4 positive a, we can just use tan of a plus b, which is nothing but tan a plus tan b divided by 1 negative tan a tan b, which is in this case is going to be tan pi over 4 plus tan a divided by 1 negative tan pi over 4 times tan a. Tan pi over 4 is 1 positive tan a divided by 1 negative tan pi over 4 is 1 times tan a. So have that in mind. This is 1 plus tan a divided by 1 minus tan a. So this is what we have got for tan pi over 4 positive a. So this is the result. So the result can also be obtained for tan pi over 4 negative a. So the sign will get reverted. So having given you all this formula, we can move on to do application oriented questions. So when I mean application oriented question, I mean how exactly or where exactly we apply these compound angle return identities. Students, we are going to see further important identities which would come in very much handy. The first one is sine of a positive b times sine of a negative b is equal to sine squared a negative sine squared b. This is a very important identity. The question is, how are we going to get it proved? So let me just start off like this. Consider the left hand side, which is sine of a positive b times sine of a negative b. We know the formula for sine of a positive b or a plus b, which is sine a cos b positive cos a sine b. This has to be multiplied with sine of a minus b, which is nothing but sine a cos b negative cos a sine b, right? So this is a plus b times a minus b, which is nothing but a squared minus b squared. So this is rewritten as sine squared a times cos squared b negative cos squared a times sine squared b. I would like to rewrite cos squared b as 1 negative sine squared b, and similarly I would like to rewrite cos squared a as 1 negative sine squared a. I would like to distribute the quantity, so that would give me sine squared a negative sine squared a times sine squared b negative sine squared b negative negative positive. This is sine squared a times sine squared b. Negative sine squared a times sine squared b would be cancelled with positive sine squared a sine squared b, thereby giving me sine squared A negative sine squared B, which is equal to right hand side, hence the result. Right, so this is a very important identity that we would be using in future. So having obtained this proof, we will move on, students. So similarly, there are two more identities which are important, and that would be involving cos of A positive B multiplied with cos of A negative B, which is equal to cos squared A negative sine squared B is the second one, and there is the third one, which is nothing but tan of A positive B positive C, which is equal to tan A positive tan B positive tan C negative tan A tan B tan C divided by 1 negative tan A tan B negative tan B tan C negative tan C tan A. Right, now next comes what we call as the transformation formulae. So we looked into the product when sine of A positive B is multiplied with sine of A negative B. Now it is addition, right, summation. So the first one is going to be sine of A positive B positive sine of A negative B is equal to 2 times sine A cos B, followed by sine of A positive B negative sine of A negative B is equal to 2 times cos A sine B. So have that in mind. So in this case it's cos A sine B. And formula 3, cos of A positive B positive cos of A negative B is equal to 2 times cos A cos B. And formula 4, cos of A followed by a negative sign cos of A positive B is equal to 2 times sine A sine B. Now having given you all this, if I were to take A positive B to be equal to C and A negative B to be equal to D, if I were to add them, this is going to be 2A is equal to C positive D. Therefore A is C positive D divided by 2. Now if I were to take the value of A and substitute it over here, then I can suitably extract the value for B, which would be C negative D divided by 2, right? Because instead of adding here, if you were to get rid of A, let me show you that also. So I get A positive B is equal to C. In this case A negative B is equal to D. I can subtract and get rid of A. So this is going to be negative, this is going to be positive, this is going to be negative. So A gets cancelled, giving me 2 times B is equal to C negative D. Therefore B is equal to C negative D divided by 2. So this is the value for B, right? So if I were to substitute them in formula 1, what would happen? So therefore I can rewrite 1 to be as sine of A positive B. In place of A positive B is going to be sine C positive A negative B, which is going to be sine D is equal to 2 times, in place of A it's going to be C positive D divided by 2 sine of C positive D divided by 2 times cos of C negative D divided by 2. So this is a important formula. Now I can just change everything. So formula 2, let me just write that down. Formula 2 can now be rewritten as sine of A plus B, which is nothing but sine C negative sine D is equal to 2 times cos of A, which is C positive D divided by 2, times sine of B, which is C negative D divided by 2. And formula number 3 is going to be cos A positive B, which is cos C positive cos of A negative B, which is D, is equal to 2 times cos of A C positive D divided by 2 times cos B, which is C negative D divided by 2. And formula number 4 is also rewritten as cos of A negative B, which is cos D negative cos A positive B C cos C is equal to 2 times of sine of A, which is C positive D divided by 2 times sine of B, which is C negative D divided by 2. Very important formula. Okay, so you will have to practice them. So practice makes perfect. Students, let's do this beautiful question by applying the formula which we just studied. So the question is given as follows: let alpha comma beta be such that alpha negative beta lies between pi and 3 pi. Now if sine alpha positive sine beta is equal to negative 21 over 65 and cos alpha plus cos beta is equal to negative 27 over 65, then we are expected to find the value of cos of alpha negative beta divided by 2. Now this is a question. Now let me start the solution in this fashion. Given, what is given? Sine alpha plus sine beta is equal to negative 21 over 65. Now there is a formula which connects sine alpha positive sine beta. What is the formula? Sine C positive sine D is equal to 2 times sine of C positive D divided by 2 times cos of C negative D divided by 2. So this is nothing but 2 times sine of alpha positive beta divided by 2 times cos of alpha negative beta divided by 2, right? So this is equal to negative 21 divided by 65. So that's what we have got. Now also what we have got also given is cos alpha plus cos beta is equal to negative 27 divided by 65. So there is also a formula which connects cos alpha added with cos beta. What is that? That's cos C positive cos D. Now that is nothing but 2 times cos of C positive D divided by 2 times cos of C negative D divided by 2. So we get cos and a cos, but in this case we get sine and a cos. So this is going to be 2 times cos of alpha positive beta divided by 2. I'm just applying the formula. Positive cos of alpha negative beta divided by 2 is equal to negative 27 divided by 65. Now I'm going to divide one by the other. Okay, so this is going to be equal to 2 and 2 can be cancelled. Cos alpha negative beta divided by 2, cos alpha negative beta divided by 2 can be cancelled. So this is going to give me sine of alpha positive beta divided by 2 divided by cos of alpha positive beta divided by 2 is equal to negative 21 over 65. I flip it, I get 65 over negative 27. They become positive. 65 gets cancelled. This is 21 over 27. Now 3 divides here 7 times, 3 divides here 9 times. So this is 7 over 9. I can rewrite this as tan alpha positive beta divided by 2 is equal to 7 over 9. Now let me go and draw the right triangle. Now this is theta, opposite side by adjacent side, hypotenuse side. Now the angle given is alpha positive beta divided by 2 and opposite side is 7, adjacent side is 9, and this hypotenuse side is going to be 9 squared positive 7 squared. So what is that? 9 squared is 81, 7 squared is 49. So what do we get? 81 added with 49, 9 added with 1, 10, carry 1. This is 12 and 13, 130. So that's going to be, this is going to be root of 130, right? From here we extract the value for sine. Therefore sine of alpha positive beta divided by 2 is going to be opposite side divided by hypotenuse side. What is opposite side? 7. Hypotenuse side is root of 130. This is for sine of alpha positive beta divided by 2. But we are expected to find the value for cos of alpha negative beta divided by 2. How am I going to get that? By using this equation, right? So if I were to name this as 2, therefore using 2 we get, what do we get? First write that down. 2 times sine of alpha positive beta divided by 2 times cos of alpha negative beta divided by 2 is equal to negative 21 divided by 65. This is going to be 2 times sine of alpha positive beta divided by 2 is 7 divided by root of 130. We need cos of alpha negative beta divided by 2, which is equal to negative 21 divided by 65. Now I have to use this part of the page, right? So if we were to flip it, or I should say cross multiply, is going to be negative 21 over 65 times root of 130 divided by 2 times 7, right? Now what happens here? 7 divides here 3 times, right? And is there anything else I can handle with? So this is simplified, so I can use this side. Negative 3 times root of 130 divided by 2 times 65. So that's going to be 130, right? So this is 130, and I can further rewrite this as 3 times root of 130 divided by, this is going to be root of 130 times root of 130. I can cancel one of this, giving me negative 3 times root of 130, right? So this is the value for cos of alpha negative beta divided by 2. So this is the solution. Of course we need to do some, some simplification is required, but it's still okay. So we have achieved the solution, and that's the important part of this particular question. Let's do this question, students. We are expected to find the value of sine 15 degrees. So how are we going to do this? Now I would rewrite sine 15 degrees to be as sine of 45 degrees negative 30 degrees, right? Then I would apply sine of a negative b formula. Now what is sine of a negative b formula? We know that sine of a negative b is sine a cos B negative cos A sin B. So by this formula, this is going to be sin 45 cos 30 negative cos 45 sin 30. Now we know that sin 45 is 1 over root 2 and cos 30 is root 3 over 2. Cos 45 is 1 over root 2. Sin 30 is 1 over 2. So this is going to be root of 3 over 2 times root 2 negative 1 over 2 times root 2. If I were to take the LCM as 2 times root 2, I would get root 3 negative 1. I wish to multiply the numerator by root 2 and divide by root 2. This would give me root of 3 times root 2 would give me root 6 negative root of 2 divided by 2 times root 2 times root 2, that's going to be 2 times 2, which is rewritten as root of 6 negative root of 2 divided by 4. So this is the value for sine 15 degrees. Now there is an interesting observation that we can make here. Now sine 15 degrees can be rewritten as sine of 90 minus 75 degrees. But what is this 90 degrees? Which is nothing but sine pi over 2 minus 75. This comes back to our popular formula which we started off in the beginning of this particular lecture. And this is going to give me cos. And in place of theta I've got 75. Now this is actually 90 minus theta. So 90 is over here between the first and the second quadrant. And minus, in this case, all ratios are positive. So that's going to be plus here. So in other words, our sine 15 is also cos 75 degrees. So have that in mind. Now, what if they ask us to find sine 75 degrees? Now this can be rewritten as sine of 45 degrees positive 30 degrees. By using the formula sine of A positive B, we get sine 45 times cos 30 positive cos 45 times sine 30. Sine 45 is 1 over root 2, cos 30 is root 3 over 2, cos 45 is 1 over root 2, sine 30 is 1 over 2. So if I were to take the LCM as 2 times root 2, this would give me root of 3 positive 1. I wish to multiply the numerator by root 2 and divide the quantity by root 2. So this is going to give me root of 6 positive root of 2 divided by 4. And what is this? This is nothing but sine 75 degrees. Students, I wish to give you further identities which are very important, which would come in very much in handy to solve questions. That would be sine A times sine of 60 negative A multiplied with sine of 60 positive A is equal to 1 over 4 times sine 3A. So this is one identity. The second one is for cos. Cos A times cos of 60 negative A times cos of 60 positive A is equal to 1 over 4 times cos 3A. Now if we were to divide 1 by 2, then we would get the third one, and that is going to be sin A over cos A. That's nothing but tan A. Similarly, sin 60 negative A divided by cos 60 negative A, that's going to be tan of 60 negative A. Sin 60 positive A divided by cos 60 positive A, that's going to be tan of 60 positive A. 1 over 4 will be cancelled with 1 over 4, giving me tan 3A. So that's a very good identity we have got, students. Now you might be wondering, how is it we are going to achieve a proof for this? Now let me just give you that foremost. Let me state the identity. This is what we have been given. Sin A times, now I would like to write this as sine of 60 positive A times sine of 60 negative A. Fair enough, it's not going to make any change at all, which is equal to 1 over 4 times sine 3A. We are expected to prove this. So what I would like to do is I would like to start off by stating, consider the left hand side. What is that? Sine A times sine of 60 positive A times sine of 60 negative A. Right? Now we know a very important result. What is that? Sine of A positive B multiplied with sine of A negative B is equal to sine squared A negative sine squared B. We just saw this result. So this would mean I can now rewrite sine A times sine of 60 positive A times sine of 60 negative A to be as sine A stays as it is, parenthesis, this is going to be sine squared of 60 negative sine squared A. Now what is sine 60? Sine 60 is root 3 over 2, right? So sine squared 60 is going to be root 3 over 2 squared, which is nothing but 3 over 4. So I would substitute that. This is equal to sine A divided by 3 over 4 negative sine squared A. If I were to take the LCM as 4, this is going to be 4 times sine squared A divided by 4, which I can rewrite it as 3 times sine A negative 4 times sine A times sine squared A. That's going to be sine cubed A divided by 4. I can take 4 out and rewrite this as 3 times sine A negative 4 times sine cubed A, which is equal to 1 over 4 times sine 3A, which is equal to the right hand side, hence the result, right? It's a beautiful result. So students, we will continue our study in the next lecture. Students, we are given this question: if A1, A2, etc. An are in arithmetic progression with common difference D, then we are expected to find the sum of the series sine D of secant A1 times secant A2 positive secant A2 times secant A3 plus etc. secant A n minus 1 times secant An. So what I wish to do is I will start off by stating this: consider sine D of secant A1 times secant A2 positive secant A2 times secant A3 plus etc. up into secant A suffix n minus 1 times secant An. Right? Now we know that, what do we know? We know that secant theta or secant A is 1 over cos theta. So because of this, I can rewrite secant A1 as 1 over cos A1, right? And so on and so forth. So that's exactly what I wish to do. So this is going to be equal to sine D times 1 over cos A1 times 1 over cos A2 positive 1 over cos A2 times 1 over cos A3 plus etc. positive 1 over cos A suffix n minus 1 times 1 over cos A suffix n. So this is what I have got. Now what I wish to do is I will now multiply sine into the parenthesis. I will distribute the sine D. Now D is a common difference, so this is going to be sine D divided by cos A1 times cos A2 positive sine D divided by cos A2 times cos A3 positive sin D divided by cos A3 times cos A4 plus etc. sin D divided by cos A suffix n minus 1 times cos A suffix n. So this is what we have got, right? Now we have to know that D is a common difference. D is given to be as the common difference. So that would mean I would be in a position to rewrite this as sine of A2 negative A1 divided by cos A1 cos A2 positive sine of A3 negative A2 divided by cos A2 cos A3 positive sine of A4 negative A3 divided by cos A3 cos A4 positive etc. Sine of A suffix n negative A suffix n minus 1 divided by cos A suffix n minus 1 times cos A suffix n. So we know a formula. Since sine of A negative B is equal to sine A cos B negative cos A sin B, using that formula I can rewrite this as sine of A2 times cos A1 negative cos A2 times sin A1 divided by cos A1 cos A2 positive, this is going to be sine of A3 times cos A2 negative cos A3 times sin A2 divided by cos A2 cos A3 and so on and so forth, right? The last term is going to be sine of A suffix n times cos A suffix n minus 1 negative cos A suffix n times sin A suffix n minus 1 divided by cos A suffix n minus 1 times cos A suffix n. So this is what we have got. So now what we have to do is we will have to use some algebraic property. Now if we were to be given A negative B divided by C, we can always write this as A over C negative B over C. So I would be using that same concept. So by that same concept I can rewrite this as sin A2 cos A1 divided by cos A1 cos A2 negative cos A2 sin A1 divided by cos A1 cos A2 positive sin A3 cos A2 divided by cos A2 cos A3 negative cos A3 sin A2 divided by cos A2 cos A3 plus etc. sin A suffix n cos A suffix n minus 1 divided by cos A suffix n minus 1 times cos A suffix n negative cos A suffix n times sin A suffix n minus 1 divided by cos A suffix n minus 1 times cos A suffix n. So we have got the terms. So now cos A1 and cos A1 gets cancelled, cos A2 gets cancelled. So this is going to be equal to, if I were to write the term, I would have this to be as sine over cos. What is that? Sine over cos. That is going to give me tan A2 and followed by sine A1 over cos A1. So what is that? That's going to be tan A1. This is tan A2, this is tan A1. In this case I can cancel cos and cos, giving me tan A3 negative. In this case I can cancel cos and cos, giving me tan A2. Okay, so now if I were to extend this, okay, what will be the next term? This is A2, this is A3. Next term is going to be tan A4 negative tan A3. So finally I will have tan A suffix n negative tan A suffix n minus 1. This is the term that we are going to have. Now let me write this vertically and show to you what's going to happen. Okay, writing the terms vertically just for your understanding. Okay, so we got tan A2 negative tan A1, tan A3 negative tan A2, of course there's a positive sign, positive tan A4 negative tan A3, and then positive, this is going to be tan A5 negative tan A4, etc., plus etc. Finally we would have tan A suffix n negative tan A suffix n minus 1, right? Now positive tan A2 negative tan A2 can be cancelled, positive tan A3 negative tan A3 can be cancelled, positive tan A4 can be cancelled with tan A4 with a negative sign. So if I were to proceed the terms in this fashion, finally everything will get cancelled and leaving us with this term tan A suffix n and negative tan A suffix 1. So this is equal to tan A suffix n negative tan A suffix 1. So this is the solution to this question, students. It's a beautiful question and we have achieved it. So we will move on to the next question. So as I always mention to you, with practice, consistency, you can achieve anything you want, right? And the most important part you have to remember is being consistent, staying consistent. As the saying goes, rain or shine, you have to be on the track, and that's the way it is. And for sure you will become successful. So having mentioned that, let me move on to the next question. So now we are going to learn what is called as multiple angles and multiple sub angles. Alright, so foremost we would have to know what is the formula for sine 2a. Now it is imperative that we know how the proof is obtained or how the formula for sine 2a is obtained. So having mentioned that, let me just rewrite sine 2a as sine a positive a, and then I can use the formula of sine of a positive b, which is nothing but, so using sine of a positive b formula. So what is that? That's going to be equal to sine a cos a positive cos a sine a. Sine a cos a and cos a sine a, that's nothing but 2 times sine a cos a. So this is a very important formula. What is it? Sine 2a is equal to 2 times sine a times cos a. So have that in mind. So next let us talk about cos. Now there is also an equivalent formula for cos 2a. So what is that? Cos 2a is written as cos of a positive a. I'm going to use cos of a positive b formula. So that is going to give me cos a negative sine a sine a. Cos a times cos a would give me cos squared a. Sine a times sine a would give me sine squared a. So this is one formula. So this is, let me write that down. Cos 2a is equal to cos squared A negative sine squared A. So this is a very important formula. Now the question comes here is, what would be the other possible formulas for this? So now what I want to do is I can actually rewrite cos squared A as 1 negative sine squared A. So if I were to do that, let's see what we are going to get. So this is going to be cos 2A is equal to, as I mentioned to you, cos squared A, I'm going to write it as 1 negative sine squared A followed by negative sine squared A. Sine squared A can be added, giving me 1 negative 2 times sine squared A. So this is another formula for cos 2A. Have that in mind. So cos 2A is also equal to 1 negative 2 times sine squared A. Now, having obtained the first formula, having obtained the second formula, now instead of writing cos squared A as 1 negative sine squared A, what would be the situation if I were to write sine squared A as 1 negative cos squared A? So let me use this part of the page. So now cos 2A is equal to cos squared A negative. I'm going to write sine squared A as 1 negative cos squared A. So this is going to be giving me cos squared A negative 1 positive cos squared A. So cos squared A is going to be 2 times cos squared A. Now there is a negative 1. Push the negative 1 to the left side. So that's going to be 1 positive cos 2A is equal to 2 times cos squared A. So this can be rewritten as 1 positive cos 2A divided by 2 is equal to cos squared A. So this is a very popular formula. Have that in mind. So it is also represented as cos squared A is equal to 1 positive cos 2A divided by 2. So that is a nice way. So we got the first one, the second one, and we've got the third formula. Now we can also go up and have the fourth one. So let's see how to get the fourth one. Now, as I mentioned to you, we can also get the fourth one. So by just moving 2 sine squared A to the left, this is going to be positive 2 times sine squared A, and I've got a 1 on the right side. What I wish to do, I would like to move positive cos 2A to the right. So that means I will get a negative cos 2A. Now I can bring the 2 down and thereby write this as sine squared A is equal to 1 negative cos 2A divided by 2. This is also a very important formula that you will have to keep in mind. So this is the fourth one. So we got 1, 2, 3, 4, and all of these 4 formulae which I've just shown you are of critical importance for solving questions. So having mentioned this, we will move on, students. Now students, having got the value for sine and cos, in other words for sine 2A and for cos 2A, we need to also get the equivalent formula for tan 2A. Now I'm going to write tan 2A as tan of A positive A, and I would be using tan of A positive B formula, which is equal to tan A plus tan B divided by 1 negative tan A tan B. So using this formula, I can now rewrite this as tan A positive tan A divided by 1 negative tan A times tan A. Tan A added with tan A would give me 2 times tan A. 1 negative tan A times tan A would give me tan squared A. So this is a very important formula, and it is imperative that we also have a note of this. So having got this, let's move on to the next one. Now, having obtained for tan 2A, there is also a relation which we can use that connects sine with tan, and also a relation that connects cos with tan, and that is as follows. Sine 2A is equal to 2 times tan A divided by 1 positive tan squared A. This is one formula, and the other one is cos 2A is equal to 1 negative tan squared A divided by 1 positive tan squared A. So this is the second one. So have that in mind. So we got a formula for tan to A, a formula for sin to A, and a formula for cos to A. Now students, let's see how to obtain this result. Now we got sin to A is equal to 2 times tan A divided by 1 positive tan squared A. I wish to consider the right hand side, which is 2 times tan A divided by 1 positive tan squared A. I'm going to rewrite tan as sin A over cos A. This is sin squared A over cos squared A. This is 2 times sin A over cos A divided by cos squared A positive sin squared A divided by cos squared A. I can flip this. This is going to give me 2 times sin A cos A. This is going to be cos squared A. Sin squared positive cos squared is 1. A cos and a cos gets cancelled, giving me 2 times sin A cos A, which is equal to sin 2A, which is nothing but the left hand side, right? So we have proved that. Now let us see how to get this result, cos 2A. So consider this is what is given, right? Okay, so let's write the formula down. Cos 2A is equal to 1 negative tan squared A divided by 1 positive tan squared A. As usual, what I will do is I will consider the right hand side, which is 1 negative tan squared A divided by 1 positive tan squared A. I will rewrite tan squared A as sin squared A over cos squared A. So this is sin squared A over cos squared A. Now taking the LCM, this is going to be cos squared A negative sin squared A divided by cos squared A. This is going to be cos squared A positive sin squared A divided by cos squared A. If I were to flip it, this is going to be cos squared A negative sin squared A divided by cos squared A. This is going to be cos squared A. When I flip it, cos squared A positive sin squared A is 1. Cos squared A gets cancelled, giving me cos squared A negative sin squared A, which is nothing but cos 2A, which is nothing but the left hand side, hence proved, right? So we have given the proof for the two formulae that we just represented here. So having given that, let's move on, students. Welcome, students. So now we will head on to find the formula for sin 3A. Now I can very well write sin 3A as sin of A positive 2 times A. Then I will apply sin of A positive B formula. So if I were to do that, this would give me sin A cos 2A positive cos A sin 2A, right? Now from here, what I wish to do is I would like to actually express or the equivalent of cos 2A. Now we have already obtained cos 2A to be as cos squared A negative sin squared A. So I would be using that over there. So this is going to be cos squared A negative sin squared A positive cos A. Sin 2A, we already know it is 2 times sin A cos A. So I can rewrite this as sin A times cos squared A negative sin cubed A positive 2 times sin A cos squared A. Now what I wish to do is I could take quantities in common. Say in this case, before we could do that, we got 2 times sin A cos squared A and we got sin A cos squared A. So why not we add these two things? So if I were to add these two things, I would get 3 times sin A cos squared A negative sin cubed A. Now I wish to write cos squared A as 1 negative sin squared A followed by a negative sin cubed A. If I were to distribute this, I would get 3 times sin A, negative 3 times sin squared A. In fact, sin squared A times sin A would give me sin cubed A, followed by negative sin cubed A. Now I can add these two together, so that would give me 3 times sin A, negative 4 times sin cubed A. So hence we now have a very important formula, which is nothing but sin 3A is equal to 3 times sin A, negative 4 times sin cubed A. So having obtained this, let us move on to obtain the equivalent formula for cos 3A. So let us consider cos of 3A. I'm going to rewrite cos 3A as cos of A positive 2 times A. I'm going to use cos of A positive B, so that would give me cos A cos 2A negative sin A sin 2A. Now this is rewritten as cos 2A is cos squared A negative sin squared A negative sin A, and sin 2A is going to be 2 times sin A cos A. I can rewrite this by distributing cos A, so it's going to be cos cubed A negative cos A times sin squared A negative 2 times sin squared A cos A. Now this is rewritten as cos cubed A. Now cos A sin squared A negative 2 times sin squared A cos A. They can be added to give us 3 times cos A times sin squared A. Since the equivalent formula is all in cos, I would like to change sin squared A as 1 negative cos squared A. So this is equal to cos cubed A negative 3 times cos A negative negative positive 3 times cos cubed A. I add these two together, this will give me 4 times cos cubed A negative 3 times cos A. So this is a beautiful formula for cos 3A. So let me rewrite that. So cos 3A as a formula, 4 times cos cubed A negative 3 times cos A. And it's imperative that you remember this formula. Now students, subsequently we also have a formula for tan 3A. So tan 3A is equal to 3 times tan A negative tan cubed A divided by 1 negative 3 times tan squared A. So let me box the formula and place that important asterisk. Students, we are given a question. Let root of 2 sin alpha divided by root of 1 positive cos 2 alpha is be equal to 1 over 7, and root of 1 negative cos 2 beta over 2 is equal to 1 over root 10, and given that alpha comma beta are element of 0 comma pi over 2, and we are expected to find the value of tan alpha positive 2 beta. So we are given this quantity is equal to 1 over 7, and root of 1 negative cos 2 beta divided by 2 is equal to 1 over root 10, and alpha and beta are present in where are they present? This is 0, this is pi over 2, they are present in the first quadrant. In first quadrant all ratios are positive. So that is a very important point we will have to observe, right? and sine is positive, cosine is positive, tan is positive, and the reciprocals are all positive in the first quadrant, and that is exactly what is being given. Now foremost, we are expected to find tan of alpha positive to beta. So let me start off by considering this tan of alpha positive to beta. Now I am going to use tan of A positive B. So if I were to use that, this is going to be tan of alpha positive tan of 2 beta divided by 1 negative tan alpha times tan 2 beta. Now let me just make use of the quantities that has been given to us. Given, what is given? Root of 2 times sine alpha divided by root of 1 positive cos 2 alpha is equal to 1 over 7. This root is extended. Now what do we know? We know that 1 positive cos 2 alpha divided by 2 is equal to cos squared alpha. So from here, what do we know? We know that 1 positive cos 2 alpha is 2 times cos squared alpha. So I would be utilizing this over here. So this would mean I now have root of 2 sine alpha divided by root of 2 times cos squared alpha is equal to 1 over 7. I can further rewrite this as root of 2 sine alpha divided by root of 2 root of cos squared alpha. 2 gets cancelled, giving me sine alpha divided by root of cos squared alpha, which is equal to sine alpha divided by cos alpha. Now why am I taking it as cos alpha? You might be asking me why I am not using modulus, but we are given that alpha and beta are present in the first quadrant, right? So on the right hand side, what do we have? We got 1 over 7, right? So let me place this sign. So this implies we got sine alpha over cos alpha is equal to 1 over 7. So what is sine alpha over cos alpha? So this would mean sine alpha over cos alpha is tan alpha is equal to 1 divided by 7. So that is what we have got. But apparently we will have to obtain tan 2 beta. Let me make use of this quantity. Okay, this quantity is already given. So from here I can literally bring about the solution for this question. All I need to do is just use this. Now since the space is exhausted, I want to go to the next page. Okay, so from here we can, as I mentioned to you, we can solve this question easily. So we know that 1 negative cos 2 beta divided by 2 is equal to sine squared beta. So from here I can rewrite this to be as 1 negative cos 2 beta is equal to 2 times sine squared beta. So this is what we have got. Now I wish to substitute 2 sine squared beta in place of 1 negative cos 2 beta. So this is going to be root of 2 times sine squared beta divided by 2 is equal to 1 over root 10. 2 can be cancelled. This would give me root of sine squared beta is equal to 1 over root 10. So this would mean I now have root of sine squared beta is sine beta is equal to 1 over root 10. As I mentioned to you, alpha and beta are present in the first quadrant, so I don't have to utilize modulus. Now let me consider the right triangle. Now why am I considering the right triangle? I need to obtain other ratios. Why? Because of the fact that I need to obtain the value for tan 2 beta. I don't know the value for tan 2 beta. I need to get it, right? So for that I need to first extract the value for tan beta. So this is going to be beta, and I got sine beta is 1 over root 10. So this is 1, this is 10. If I were to take this as A, B and C, I got AB squared positive BC squared is AC squared. My AB squared I don't know. my BC squared is 1 squared, my AC squared is 10. So AB squared is equal to 10 negative 1, which is 9. So AB is equal to root of 9, which is equal to 3. So this is 3 units. So from here, tan beta is opposite by adjacent. So 1 over 3. So that is a good value for tan beta. So now, having obtained the value of tan beta, we have to obtain the value for tan 2 beta, right? So let's obtain the value for tan 2 beta. Now I would like to write tan 2 beta as tan of beta positive beta. This is tan of A positive B. This is going to be tan beta positive tan beta divided by 1 negative tan beta times tan beta, which is equal to 2 times tan beta divided by 1 negative tan squared beta. Now 2 times tan beta is 1 over 3, so this is 1 over 3 divided by 1 negative tan beta is 1 over 3, so it's going to be 1 over 3 raised to the power of 2, which is equal to 2 over 3 divided by 1 negative 1 over 9, which is nothing but 2 over 3 divided by 9 negative 1 divided by 9, which is 2 over 3 divided by 8 divided by 9. If I were to flip it, I get 2 over 3 times 9 over 8. 3 divides here 3 times, 2 divides here 4 times. So I get 3 over 4. So tan 2 beta value is 3 over 4. But this is not the end of the question. So now we are expected to obtain tan of alpha positive 2 beta, right? So if I were to expand this, we know that this is tan alpha positive tan 2 beta divided by 1 negative tan 2 beta. This is what we have got, right? So tan alpha is 1 over 7 and tan 2 beta is 3 over 4 divided by 1 negative tan alpha is 1 over 7 multiplied with tan 2 beta is 3 over 4, right? So this is going to be 25 divided by 28 divided by 1 negative 3 divided by 28. So this is 25 over 28 divided by 28 negative 3 divided by 28. So let me write that down here. So this is equal to 25 over 28 divided by 28 negative 3 would give me 25 divided by 28. Now you can clearly see that 25 over 28 and 25 over 28, they can both get cancelled, giving us 1. Therefore the value of tan of alpha plus 2 beta is equal to 1, and that completes the solution for this question. Students were asked to find the value of this question: cos square 10 degrees negative cos 10 degrees times cos 50 degrees positive cos square 50 degree. So foremost, let me consider the given question. Cos square 10 degrees negative cos 10 degrees cos 50 degrees positive cos squared 50 degrees. Now what I wish to do, I would like to multiply the numerator by 2 and divide by 2, right? And then I would like to distribute this 2 inside. So this would give me 2 times cos squared 10 degrees negative 2 times cos 10 degrees cos 50 degrees positive 2 times cos squared 50 degree. Now there is a 2. Let me product multiply it like this. Okay. Now I have a formula. We know that 1 positive cos 2 theta is equal to 2 times cos squared theta, right? Now if I were to take theta to be as 10, if I take theta to be as 10 degrees, then this would become 1 positive cos 2 times 10 degrees is equal to 2 times cos squared theta is 10, right? So this is going to be 1 positive cos 2 into 10 will give me cos 20 is equal to 2 times cos squared 10 degrees. So in place of 2 times cos squared 10 degrees, I'm going to substitute 1 positive cos 20 degrees. So let me do that. So this is equal. This is going to be giving me 1 over 2 times. This is 1 positive cos 20 degrees negative. I'm going to take the negative sign out and rewrite this as 2 times cos 50 degrees times cos 10 degrees, and I have a 2 times cos 50 degrees. Now if I were to take theta to be as 50 degree, what would happen? Say theta is equal to 50 degree, what would happen here? Let me write that down here. So this is going to be 1 positive cos of 2 times of 50 is equal to 2 times of cos squared 50 degrees, right? So this is going to be 1 positive cos 100 is equal to 2 times cos squared 50 degrees. So in place of 2 times cos squared 50 degree, I can have 1 positive cos 100 degrees, right? So that's exactly what I've got. So now this is nothing but, now this one, this is of the form, let me write that down here. This is nothing but 2 times cos A cos B, which has a formula cos of A positive B positive cos of A negative B. So I can very well use this formula. So what would happen if I were to use this formula? This is equal to 1 over 2 times 1 positive cos 20 degrees negative, so cos of A positive B, so 50 positive 10 positive cos of 50 negative 10 positive 1 positive cos 100. Now let me rewrite that. That's equal to 1 over 2 times 1 positive, I'm lightening it with some clarity, negative of cos 50 positive 10, that's going to be cos 60 degrees, positive cos 50 minus 10, that's going to be cos 40 degrees. I got a positive 1 positive cos 100 degrees. Now I can add 1 and 1, so that's going to be 1 over 2 of 2 positive cos 20 degrees negative. Now I'm just going to retain them as it is, and then in the next step I will perform the evaluation. So open the parenthesis. Cos 60 is 1 over 2, cos 40 has to be retained, positive, I've already added this 1, I got cos 100 degrees, so this is what I've got. Now I can rewrite this as 1 over 2 times 2 negative 1 over 2, so they go together. So I've got a cos 20 degrees and negative cos 40 degrees. So I can club these two together, followed by a cos 100 degrees. So this is what I've got. Now we can make use of this formula. So we know that cos C negative cos D is equal to negative 2 times, it should be in sine, right, because of the negative sign, sine of C positive D divided by 2 times sine of C negative D divided by 2, right? So we can utilize this formula. So therefore cos of 20 degrees negative cos 40 degree is equal to negative 2 times sine of 20 positive 40 divided by 2 times sine of 20 negative 40 divided by 2. So this is what you are getting. So this is equal to negative 2 times, this is 20 positive 40, that's going to be 60 divided by 2, that's sine 30, and times sine of 20 minus 40, that's negative 10 degrees. Now sine is an odd function, so this is going to be positive 2 times. Now sine 30 is 1 over 2, and I get sine 10 degree, so which is nothing but sine 10 degrees. So that's exactly what we have got there. So now let me write that down. So this is equal to 1 over 2 times 2 times 2, 4 more negative 1, that's going to be 3 over 2, a positive sine 10 degree, positive cos of 100 degree. I'm going to write cos of 100 degree as cos of 90 degree, positive 10 degrees. Okay, I can write that. So this is actually, let me just show that here. This is nothing but cos of pi over 2 positive theta, which is going to be plus or minus sine theta, right? So 90 positive theta, where is 90 positive theta? Let me use the space. This is 0, this is 90. 90 positive theta is over here. Over here, sine alone is positive, right? Cos is not positive. Cos is going to be negative here. So this is going to be giving us negative sine theta. So that would mean we got 1 over 2 of 3 over 2, positive sine 10 degree and negative sine 10 degrees. So positive sine, negative sine gets cancelled, giving us 1 over 2 times 3 over 2, which is nothing but 3 over 4, which is the solution for the question. Students, we are given a beautiful question. We are expected to find the value of sine 10 degrees times sine 30 degrees times sine 50 degrees times sine 70 degrees. Right? Now I'm going to rewrite this as sine 10 degrees times sine 30 is 1 over 2, and sine 50, I wish to write sine 50 as sine of 60 negative a, and sine 70 I wish to write it as sine of 60 positive a. Now I would like to rewrite this entire thing as 1 over 2 times sine, my a in this case is going to be 10 degrees. Okay, so I'm going to write that a is equal to 10 degrees. So if I were to do that, this is going to be sine 10 degrees times sine of 60 negative 10 times sine of 60 positive 10. Now we have a formula, right? So what is the formula? Let me write that formula down here. Now we know that sine a times sine of 60 negative a times sine of 60 positive a is equal to 1 over 4 times sine 3 times a. So that is the formula we will be using. So in this case, when a takes the value 10, 10, 10, we are in a position to produce the exact quantities of sine 10, sine 50, sine 70. So that would mean we can rewrite this to be as 1 over 4 times sine of 3 times my a is 10 degrees, right? So this is equal to 1 over 8 times sine 30. Sine 30 is 1 over 2, which is nothing but 1 over 16. So this is the solution to this question. Students, we are given a beautiful question. We are expected to find the value of the following expression. Okay, so let me write that down. We have been given cos cubed pi over 8 times cos 3 pi over 8 positive sine cubed pi over 8 times sine 3 pi over 8. So this is the expression that's been given, and we are expected to find the value. Now, of course, you are not allowed to use a calculator. If you are allowed to use a calculator, it's easy to obtain the value. But without the use of calculator, we can still obtain the value. So foremost, what I wish to do is, I would like to take, let pi over 8 be equal to theta, and I will multiply both sides by 3. So it's going to be 3 pi over 8 is equal to 3 theta. So I've got a substitution for theta, I got a substitution for 3 theta. Now what I wish to do is, I would also like to multiply both sides by 2. So it's going to be 2 pi over 8 is equal to 2 theta. So from here I can write 2 theta is equal to pi over 4. Now the objective is to ensure that 2 theta is present in the expression. If it isn't, I will have to make sure that 2 theta is somehow brought into existence into the expression. So that is the main objective. So with this substitution, I can rewrite this as cos cubed theta times cos 3 theta positive sine cubed theta times sine 3 theta. Now cos cubed theta, I will have to retain it as it is. But cos 3 theta, I know a formula which is cos 4 times cos cube theta negative 3 times cos theta, right? Positive sine cube theta. For sine 3 theta, I know a formula which is 3 times sine theta negative 4 times sine cube theta, right? We have already obtained the proof for these two things in the previous working. Now I can actually split this. I can rewrite this as 4 times cos cube theta into cos cube theta. This is going to be cos raised to the power of 6 theta negative 3 times cos raised to the power of 4 theta positive 3 times sine raised to the power of 4 theta negative 4 times sine raised to the power of 6 theta. I will club these two together. So this is equal to 4 times of cos raised to the power of 6 theta negative sine raised to the power of 6 theta, and I will club these two together. Positive 3 times sine raised to the power of 4 theta negative cos raised to the power of 4 theta. So this is what I've got. So my point is, I would like to take the negative sign out from here. If I were to take the negative sign out, I can rewrite this as 4 times cos 6 raised to the power of 6 theta negative sine raised to the power of 6 theta. The reason I'm taking negative sign out is I want to have cos as the first leading term. So that's going to be negative 3 times of cos raised to the power of 4 theta negative sine raised to the power of 4 theta. So I've got this. Now I wish to rewrite this as 4 times of cos squared theta raised to the power of 3 negative sine squared theta raised to the power of 3 negative 3 times. So I wish to write this as cos squared theta raised to the power of 2 negative sine squared theta raised to the power of 2. So this is equal to, or rewritten as 4 times. Now a cubed negative b cubed. So what is the formula for that? A cubed negative b cubed is equal to, we start with a negative b times a squared positive ab positive b squared, right? So if I were to use this formula here, I got a cos squared theta raised to the power of 3 negative sine squared theta raised to the power of 3. So this is a and b. So this is going to be cos squared theta negative sine squared theta times, so if I were to square that, This is going to be cos raised to the power of 4 theta positive cos squared theta sine squared theta. Okay, positive sine raised to the power of 4 theta. So this is what we are going to have. So I need to take this. This is just for your understanding. I need to take this and substitute it here. So this is going to be cos squared theta negative sine squared theta times, I'm going to rewrite this as cos squared theta, cos raised to the power of 4 theta positive sine raised to the power of 4 theta. Okay, positive cos squared theta sine squared theta. Nothing is being done, just placing the quantities, right? So we will have to close this off. So this is for the first term, negative 3 times of a squared negative b squared. So what is that? A squared negative b squared. So that is going to be cos squared theta negative sine squared theta. This is multiplied with cos squared theta positive sine squared theta. This is going to be 1, right? So we are left with 4 times cos squared theta negative sine squared theta, and multiplied with, now I can actually club these two together. So I've already clubbed this, so this has got a formula. So there's going to be 1 negative 2 times sine squared theta times cos squared theta, right? So probably I will just write that down. So this is going to be 1. I need to, let me strike this off, because if I were to shade this off, it would be a little bit untidy. So I will move this off and I'll rewrite this. So there's going to be 4 times of cos squared theta negative sine squared theta times, this is 1 negative 2 times sine squared theta cos squared theta positive cos squared theta sine squared theta. So this is one term, negative 3 times I got cos squared theta negative sine squared theta, right? Now I can add these two together. So this is going to be 4 times of cos squared theta negative sine squared theta times 1, right? You are adding these two together, so that would give me negative sine squared theta times cos squared theta. So that is okay. We can place the parenthesis here, followed by negative 3 times cos squared theta negative sine squared theta. Now what I wish to do is I would like to take cos squared theta negative sine squared theta out. So if I were to do that, cos squared theta negative sine squared theta, the first term I would get would be 4 times of 1 negative sine squared theta times cos squared theta, followed by a negative 3, right? So this is cos squared theta negative sine squared theta. This is nothing but cos 2 theta times 4 times 1 is 4, 4 times sine squared theta cos squared theta negative 3. This is equal to cos 2 theta, 4 added with negative 3 would give me 1, followed by 4 times sine squared theta cos squared theta. I wish to write this as 2 times sine theta cos theta raised to the power of 2. Now this is equal to cos 2 theta of 1 negative, now 2 sine theta cos theta is nothing but sine 2 theta. So this is sine 2 theta raised to the power of 2. Okay, right? Now we got 2 theta is equal to what? Pi over 4. We started with this. Substitute that. So this is equal to cos of pi over 4, 1 negative sine of pi over 4 raised to the power of 2, which is nothing but 1 over root 2. It's pi over 4 is 45, right? So this is 1 over root 2 times 1 negative 1 over root 2 raised to the power of 2 is going to be 1 over 2. Now this is going to be 1 over root 2, 2 negative 1 divided by 2, which is nothing but 1 over 2 times root 2, right? And this is the solution for the question. So students, I hope you enjoyed this, and we will meet again in the next class. Have a nice night. Students, we are given a question. This question occurred in JEE Advanced in the year 2020. So the question is, f is defined from closed interval 0, 2 to set of real numbers, and it is defined by f of x is equal to 3 negative sine of 2 pi x times sine of pi x negative pi over 4 negative sine of 3 pi x positive pi over 4. So this is how the function is defined. And furthermore, if alpha comma beta are present in the closed interval such that for x contained in the closed interval, f of x is greater than or equal to 0, and that is given to be equal to alpha comma beta, then find the value of beta negative alpha. So this is quite a question. Now foremost, what we have to do is we will have to use the function, and then we will have to reduce the function to the given information. So that is exactly what we are going to do, so that from there on we will be able to extract the values for alpha and beta. So let me just start off like this. Let me consider 3 negative sine of 2 pi x times sine of pi x negative pi over 4 negative sine of 3 pi x positive pi over 4. Now what I wish to do is I wish to let pi x negative pi over 4 to be equal to some theta. So from here I can rewrite pi x to be equal to, I can move this pi over 4 to the right, so that's going to be pi over 4 positive theta. Now we need to get 2 pi x, so multiplying by 2 both sides we get, so this is going to be 2 pi x is equal to pi over 2 positive 2 times theta. So I have got the value for pi x negative pi over 4 for 2 pi x. Now I need to get 3 pi x. So from here what I wish to do is I would like to multiply by 3 both sides, right? So if I were to do this to this equation or to this assignment, this would produce me 3 pi x is equal to 3 pi divided by 4 positive 3 theta. Now I would want to, or I should get 3 pi x positive pi over 4. So adding pi over 4 both sides, this is going to be 3 pi over 4 positive pi over 4 positive 3 theta, which is going to give me pi positive 3 theta. So let me use all of these values in the given function or in the given system. So this is going to lead us to 3 negative sine of 2 pi x. That's going to be pi over 2 positive 2 theta parenthesis sine of pi x negative pi over 4. That's going to be theta negative sine of 3 pi x positive pi over 4. That's going to be pi positive 3 theta. Now clearly this is going to give me cos 2 theta. We have already studied this. But apparently if you were to check the quadrant, this is 0, this is 90, this is 180, this is pi over 2 positive. So sine is positive here. But apparently because we got negative, so this is going to be negative cos 2 theta times sine theta negative sine pi, sine of pi positive theta. This is going to be sine 3 theta undoubtedly. But positive means over here tan alone is positive, so this is going to be negative of sine theta. So I can rewrite this as 3 negative cos 2 theta times sine theta positive sine 3 theta. So this is going to be equal to, now we will have to rewrite everything in sine. I want to know if I can take anything out. Okay, it is not possible as of now. So let me convert cos 2 theta. I'm going to use cos 2 theta is equal to 1 negative to sine square theta formula. So if I were to use that formula, I would have 3 negative of 1 negative 2 sine square theta times sine theta positive 3 sine 3 theta is going to be 3 times sine theta negative 4 times sine cube theta. So this is going to be 3 negative 1 positive 2 times sine square theta times sine theta followed by 3 times sine theta negative 4 times sine cube theta. So this is going to be 3 negative 1 2 positive 2 times sine square theta times sine theta positive 3 times sine theta negative 4 times sine cube theta. What I wish to do is I would like to distribute sine theta. So that's going to give me, because of the presence of negative 4 times sine cube theta, so this is going to be 2 times sine theta positive 2 times sine cube theta positive 3 times sine theta negative 4 times sine cube theta. So I can add these two together, so that would give me 2 times sine theta positive 2 sine cube theta negative 4 times sine cube theta would give me negative 2 times sine cube theta positive 3 times sine theta. So this is what we have got. Now if I were to take sine theta out, so if I were to take sine theta out, this would give me 2 positive 3, okay, followed by 2 times sine cube theta. So this is going to be equal to, let me just write this down. So this is going to be 5 sine theta negative 2 times sine cube theta. So if I were to take sine theta out, this is going to be 5 negative 2 times sine square theta. Now what is this? What is all of this? This is nothing but the function f of x, right? You see that? This is f of x given, and it says that for x being present in the closed interval 0, 2, f of x is greater than or equal to 0. So we have to apply that. So this is greater than or equal to 0. Now clearly this is going to be positive, right? And that would mean, because this entire term is going to be great, it has to be greater than or equal to 0 according to the definition of f of x. So this is clearly positive because of the value that sine takes. Okay, so because of that, when this is positive, the product multiple with sine theta should ensure that we are getting greater than or equal to 0. So naturally, if this is positive, this would imply that sine theta is greater than or equal to 0. Right? So having got that, we know that, but theta is what? Theta is equal to pi x negative pi over 4. So we can make use of this particular data. But from the graph of sine x, we know that the graph is like this, right? And theta lies between 0 and pi, right? So from here I can clearly state that this would mean the value of theta is between 0 and pi. But we have already taken theta to be equal to pi x negative pi over 4. So that would mean 0 less than equal to pi x negative pi over 4 less than equal to pi. Now adding pi over 4 both sides, we get pi over 4 less than equal to pi x negative pi over 4, positive pi over 4 less than equal to pi positive pi over 4. Negative pi over 4, positive pi over 4 gets cancelled, giving us pi over 4 less than equal to pi x less than equal to 5 pi over 4. Cancelling the pi, we get 1 over 4 less than equal to x less than equal to 5 over 4. So this is the interval that x is lying. So once we have obtained the interval, this would mean clearly alpha is going to be equal to 1 over 4 and beta is equal to 5 over 4. Now we are expected to find the value of beta negative alpha. So that would mean 5 over 4 negative 1 over 4, which is 4 divided by 4, which is equal to 1. So this would mean the value of beta negative alpha is equal to 1. So this is the solution to this question. Students, will move on to the next one. Students, let's do this question. Two parallel chords of a circle of radius 2 are at a distance of root of 3 positive 1 apart. If the chords subtend at the center, angles of pi over k and 2 pi over k, k being greater than 0, we are expected to find the value of k. Now this question occurred in JEE 2010 advanced. So let us draw a circle first, and we have got two chords which are parallel to each other and they are separated by a distance of root of 3 positive 1. So this is the distance. It's given that each of these chords are subtending an angle at the center. So I can clearly have this to be as, now the entire angle subtended by chord 1 is pi over k. So this is going to be, let me write that down here, pi over 2k, right? And similarly this chord C2 also subtends an angle, and that's the entire angle subtended by chord 2 is 2 pi over k. So this is going to be pi over k, right? So now if I were to use the right triangle property, then I can clearly see that. Now let me just draw this part alone. So this is how it looks, right? This is one part, and this is going to be pi over 2k. This angle is pi over 2k, so this is going to be my opposite side, this is my adjacent side, and this is my hypotenuse side, right? So if I were to take the adjacent side, so let me just take this as O, A and B. So if I were to take cos, right, cos of pi over 2k, that is going to be equal to adjacent side by hypotenuse side. So this is cos of pi over 2k. My adjacent side is required, but my hypotenuse side, I can easily see the hypotenuse side from the radius. Now clearly it says the radius is 2 units. You see that? This is 2 units. So this is going to be 2 units. So this is going to be 2. So therefore adjacent side, which is OA, can be rewritten as OA is equal to 2 times cos of pi over 2k. Right? That's one part. The next part, similarly, if I were to consider this part, so let me just consider this part. So this is how it looks. So I have an angle of pi over k. So this is going to be my opposite side, this is my adjacent side. So if I were to take cos again, so from here cos pi over k is adjacent side, so this I have taken it as O, right? And if I were to take this as B, so this is my O, this is my B, so OB over hypotenuse side, which is 2. So this is going to be OB equal to 2 times cos of pi over k. So I've got it like this. Now two chords are actually separated by root of 3 positive k. So this would mean root of 3 positive 1 is equal to OA positive OB, right? This is given actually. So from here I can rewrite root of 3 positive 1 is equal to my OA is 2 times cos of pi over 2k positive my OB is 2 times cos of pi over k. So this is what I have got. Now what I wish to do is I would like to take, probably I can use this space here, let pi over 2k be equal to theta. If pi over 2k is equal to theta, what would be pi over k? I mean, in this case it's pi over 2k and we are taking it to be theta. Now I just want to get the value for pi over k. So that would mean I would have to multiply both sides by 2. So this would give me 2 times pi over 2k is equal to theta. So 2 gets cancelled. Therefore pi over k is equal to 2 theta. So I've got one value here, I got one value here. So if I were to take this as 2, therefore I can rewrite 2 to be as root of 3 positive 1 is equal to 2 times cos theta positive 2 times cos pi over k is cos 2 theta. So this is what I have got. Now this is a solvable system and I'm going to show you how to solve it. Of course this is solvable, but we need to perform some manipulation. So what I wish to do is I would like to rewrite this as 2 times cos theta positive. Now 2 times cos 2 theta, I'm going to rewrite this as 2 cos squared theta negative 1. We have seen a formula like this. So this is equal to root of 3 positive 1. I can rewrite this as 4 times cos squared theta negative 2 positive 2 times cos theta is equal to root of 3 positive 1. Further, I can rewrite this as 4 times cos squared theta, positive 2 times cos theta, and I can move this to the left side. So negative 2, negative 1, negative root of 3 is equal to 0. Rewriting this, I get 4 times cos squared theta, positive 2 times cos theta, negative 3 negative root 3 is equal to 0, which I can further rewrite it as 4 times cos squared theta, positive 2 times cos theta. I can take a negative sign out and write this as 3 positive root of 3 is equal to 0. Right? So now this is a quadratic equation and we will have to solve this. So if I were to use the quadratic formula, taking a is equal to 4 and b is equal to 2 and c is equal to negative of 3 positive root of 3. So that's going to be negative b plus or minus root of b squared negative 4 times ac divided by 2 times a. So this is equal to negative, my value for b is 2, plus or minus root of b squared is 4, negative 4 times, my a is 4 and my c is negative, so this is going to be positive 3 positive root 3 divided by 2 times a is 4. So I can rewrite this as negative 2 plus or minus root of 4 positive, this is 4 squared times 3 positive root of 3 divided by 8. I can take 4 out. If I were to take 4 out, I would get 1 positive 4 times of 3 positive root 3 divided by 8, which is negative 2 plus or minus. I can take 4 out. This is going to be 2 times root of 1 positive 4 times 3 is 12 positive 4 times root of 3 divided by 8. Now if I were to take 2 out, this is going to be negative 1 plus or minus root of 1 positive 12. I could have added it, but anyway. So divided by 8, which is equal to 2 divides 8 4 times. So it's going to be negative 1 plus or minus root of 12 added with 1 would give me 13 positive 4 times root of 3 divided by 4. So this is what we have got. Now the question comes, what is the value of 13 positive 4 times root 3? Is it possible for us to represent it as a perfect square? Of course, if I were to rewrite it like this, 2 times root of 3 squared, this is going to give me 4 times 3 12, added 1 would give me 13, that's fine. Positive, I need to get a 4 there, so 2 times 2 root 3, right? So this is going to be a squared plus b squared plus 2ab. So if I were to write this, this is going to be 2 times root 3 squared positive 1, right, raised to the power of 2. So square this, you get the first term, and you multiply 2ab is going to be 2 times of 2 times root 3 times 1, and square this up, so that's perfect. So we have achieved representing 13 positive 4 times root of 3 as a perfect square. So just substitute it there. So this is equal to negative 1 plus or minus root of 2 times root 3 positive 1 raised to the power of 2 divided by 4. And see that there will be two values. So cos theta is equal to negative 1 plus, in fact, let me write this down. Cos theta is equal to negative 1 plus or minus 2 times root 3 positive 1 raised to the power of 2 divided by 4. Now when I take the square root, I would have cos theta to be equal to negative 1 positive 2 times root 3 positive 1 divided by 4. This is one value. The other value would be negative 1 negative of 2 times root 3 positive 1. Okay, so this, let me write this down here. This would be the next value. Cos theta is equal to negative 1 negative of 2 times root 3 positive 1 divided by 4. Now this is producing all negative, so we drop this. Okay, so we will only be taking the positive value. So if I were to take the positive value, this is going to be negative 1, positive 2 times root 3, positive 1 divided by 4. Negative 1, positive 1 gets cancelled, giving me 2 times root 3 divided by 4. 2 divides 4 2 times, which is root of 3 divided by 2. We have got cos theta is equal to root 3 over 2. So this would mean our theta is equal to pi over 6. But we have taken theta to be equal to pi over 2k. This is how we started with, right? So this would mean if I were to equate both the things, I would get pi over 2k is equal to pi over 6. Pi can be cancelled. So this would mean 6 over 2 is equal to k. Therefore, the value of k is equal to 3. So this would be the solution to this question. So having got this, let's move on to the next one, students. Students, now we will move on into understanding the cosine series. Now the series is as follows. So we got cos A times cos 2A times cos 4A times cos 8A, etc. cos 2 raised to the power of n minus 1 times A is equal to sine of 2 raised to the power of n times A divided by 2 raised to the power of n times sine A. So the question now is, how are we going to prove this? So foremost, what I wish to do is, I would like to consider the left hand side. So what is on the left hand side? You get cos A times cos 2A times cos 4A times cos 8A, etc., all the way to cos 2 raised to the power of n minus 1 times A. Now what I would like to do is, I would like to multiply the numerator by 2 times sine A and divide it by 2 times sine A. So if I were to do that, this is equal to 2 times sine A cos A, and so on it goes. So let me club these two terms. If I were to club these two terms, this would now be equal to sine 2A times cos 2A times cos 4A times cos 8A, etc., cos 2 raised to the power of n minus 1 times A divided by 2 times sine A. Now I can multiply by 2 and divide by 2, so this is going to be 2 squared. Okay, so I can rewrite this term as, this is going to be equal to sine 2, instead of the angle A, I've got 2A, so it's going to be 2 times of 2A times cos 4A times cos 8A, etc., up onto cos 2 raised to the power of n minus 1 times A divided by 2 squared times sine A. So this is what I have got. Now I can rewrite this as sine 4A times cos 4A times cos 8A, etc., cos 2 raised to the power n minus 1 A divided by 2 squared times sine A. If I were to continue this, now if I were to multiply this by 2 and divide by 2, I can clearly club these two together and rewrite this as sine 2 times of, the angle is 4A, so this is going to be 4A times cos 8A, etc., cos 2 raised to the power of n minus 1 times A divided by 2 raised to the power of 3 times sine A. Now this is equal to sine 8A times cos 8A, etc., cos 2 raised to the power of n minus 1 times A divided by 2 raised to the power of 3 sine A. Now clearly you can see that now this is actually 8 and this is also 8, right? So if I were to express this, so extending this is clearly going to be sine of 2 raised to the power of n times A divided by 2 raised to the power of n times sine A. So that is exactly the series that we have on the right hand side. Students, we will do an interesting question. We are expected to prove cos pi over 15 times cos 2 pi over 15 times cos 3 pi over 15 times cos 4 pi over 15 times cos 5 pi over 15 times cos 6 pi over 15 times cos 7 pi over 15 is equal to 1 over 1 to 8. Now foremost what I wish to do is I would like to use the cos series double angle formula which I have just explained in the previous page. So if I were to use this, I will have to take every angle which is represented as the multiple of 2 times the previous angle. So I would take cos pi over 15. I've got no other option. I need to take this. This is the first term. So if I were to multiply this by twice, this is going to give me cos 2 pi over 15. So that is over here. So I can take this off. So this is cos 2 pi over 15. So 2 of these terms have already been exhausted. So if I were to multiply this angle by twice, that would give me cos 4 pi over 15. So that's already here. So let me write that down. Cos 4 pi over 15. So that's fine. So if I were to multiply this by 2 or twice, it will give me cos 8 pi over 15. But I have only 7 pi over 15. But I can write 7 pi over 15 as cos of pi negative 8 pi over 15, right? It's possible. So cos of pi negative theta, this is going to be cos of 8 pi over 15. If I were to represent this by the quadrant, this is going to be in the second quadrant where cosine is negative. So this is going to be negative. So instead of cos of 7 pi over 15, I have to now use cos of 8 pi over 15, right, with the negative sign. So I can very well place a negative sign and write this as cos of 8 pi over 15. Fair enough. Now we are left with cos 3 pi over 15 and cos 6 pi over 15 and cos 5 pi over 15. Now 5 divides here 3 times, so cos 3 pi, this is going to be cos of pi over 3. Now cos of pi over 3 is nothing but cos 60. Cos 60 is 1 over 2, so we can place that 1 over 2 over here. So now we are left with cos 3 pi over 15. Multiply this by 2, you get cos 6 pi over 15. So that's there, cos 6 pi over 15. And we can now use the formula which we just got in the, as I mentioned to you. So this is going to be negative 1 over 2 times sine of 2 raised to the power of 5. Count the number of terms, 1, 2, 3, 4. So 2 raised to the power of 4, and the angle pi over 15 divided by 2 over 4 times sine pi over 15, right? Now this can be simplified in the following manner. Now for this we got 2 terms here, so this is going to be sine of 2 raised to the power of 2. The angle is 3 pi over 15 divided by 2 raised to the power of 2 times sine of 3 pi over 15. So now we will have to rewrite this. Of course, for the last term I already mentioned to you, this is 1 over 2. I've already placed it there. So we have to now adopt the following simplification. So this is going to be equal to negative 1 over 2. Now sine of 2 raised to the power of 4. 2 to the 4, 4 times 2, 8. 8 times 2 is 16. So this is 16 pi over 15 divided by 2 raised to the power of 4. That's 16 sine pi over 15 times sine 2 to the 4, 4 times 3 is 12 pi over 15 divided by 2 squared is 4 sine 3 pi over 15. So this is what we have got. So now what I wish to do is I would like to rewrite sine 16 pi as sine of pi positive pi over 15. 15 times pi is 15 pi positive pi gives me 16 pi divided by 16 times sine pi over 15. I'm not going to do anything with that. Now this multiplied with sine of 12 pi. Can I write sine of 12 pi as pi negative 3 pi over 15? 15 times pi is 15 pi, negative 3 pi will give me 12 pi. So sine 12 pi over 15 is achieved divided by 4 times sine 3 pi over 15. So we are not going to do anything with that. Now this is sine pi of pi over 15. So that's nothing but we already know that's going to be sine pi, but it is actually in the third quadrant, right? Positive. So in this case sine is negative. So this is going to be sine of pi over 15. Sine is negative, so I place the negative sign there, divided by 16 times sine pi over 15. Now this is sine of pi pi minus 3 pi, right? So I can rewrite this as sine of 3 pi over 15. This is negative, right? So negative means in this quadrant sine is positive, so we got a positive sign there, divided by 4 times sine 3 pi over 15. Now sine 3 pi over 15, sine 3 pi over 15 gets cancelled, sine pi over 15, sine pi over 15 gets cancelled. So we have got negative negative positive. 16 times 4, that's going to be 6 4s are 24, 2 4 on the 4 5 6, 64 multiplied by 2 is 128, which is equal to the right hand side. So that is the end of the solution, students. Students, we are given a beautiful problem. We are expected to prove sine of pi over 14 times sine of 3 pi over 14 times sine of 5 pi over 14 times sine of 7 pi over 14 is equal to 1 over 8. So foremost what I wish to do is I would like to consider the left hand side. So this is going to be sine of pi over 14 times sine of 3 pi over 14 times sine of 5 pi over 14 times 7 pi over 14. 7 divides here 2 times, pi over 2 is sine 90, that's going to be 1, right? Now we only have cosine series, we do not have anything for sine. So what I wish to do is I would like to convert everything into cos. So how do I do that? By using this formula. We know that sine theta is equal to cos of 90 minus theta. So using this formula I would represent every angle in this fashion. So this is going to be cos of 90. So it's going to be pi over 2 negative pi over 14 times cos of pi over 2 negative 3 pi over 14 times sine of cos of pi over 2 negative 5 pi over 14. So this is what we have got. Now this is equal to, if I were to take the LCM as 14, this would give me 14 and 7 pi minus pi, right, times cos of, I take the LCM as 14, 7 pi minus 3 pi times cos of 14, this is going to be 7 pi negative 5 pi. So this is cos of 6 pi over 14, right, times cos of 4 pi over 14 times cos of 2 pi over 14. So clearly we can see twice of 2 pi over 14 gives me cos of 4 pi over 14. Twice of 4 pi over 14 should give me 8 pi over 14, but we do not have 8 here. But we can bring an 8 inside. So how do I do that? So this is going to be cos of, I need to have 8 pi over 14, right? So the only way it's possible is just subtract pi negative of 8 pi over 14. That would give me 6 pi over 14. So this is going to be cos of 4 pi over 14 times cos of 2 pi over 14, right? So this is actually cos of 8 pi over 14, but let's go to the quadrant. Pi negative, so that means second quadrant, so that means cosine is negative here, so you get a negative sign there. So times cos of 4 pi over 14 times cos of 2 pi over 14. So this is the smallest angle, so this is what we have got. If we were to use the series formula and write the equivalent terms for the above series, then we would now have negative of sine of 2 raised to the power of 3 times, it's actually 2 pi over 14, this is the smallest angle, right, divided by 2 raised to the power of 3 sine of 2 pi over 14. So this can be further rewritten as negative, now this is 8, now 2 divides 14 7 times, right, so this is going to be 8 pi over 7 divided by 8 times sine of pi over 7. So this is what we've got. Now I can rewrite 8 pi over 7 in the following fashion. So this is going to be sine of pi positive 7, right? 7 times pi would give me 7 pi positive pi, gives me 8 pi over 7. So just to reiterate what I have done, we got a negative sign, so I'm applying the series formula which we had already obtained. So this is going to be sine of 2 raised to the power of 3 times 2 pi over 14 divided by 2 raised to the power of 3 times sine 2 pi over 14. Reducing, we get negative sine of 8 pi over 7 divided by 8 times sine pi over 7. Now I'm writing 8 pi over 7 as sine of pi positive pi over 7, but because 7 times pi would give me 7 pi positive pi, that's going to be 8 pi over 7 divided by 8 times sine of pi over 7. But if I were to simplify this, so this is nothing but sine of pi, but it is actually positive, right? So this is over here in this quadrant, tan alone is positive. Of course the reciprocal is also positive, but sine is negative, so that negative would be neutralized by this negative, giving us positive. So this is going to be sine of pi over 7 divided by 8 times sine of pi over 7. Clearly sine of pi over 7 and sine of pi over 7 will get cancelled, giving us the solution 1 over 8, which is nothing but the right hand side, and hence the result is proved, right? So that completes the solution for this question. Students, we will move on. Students, welcome to the class. We will start off with this particular question. We are expected to find the value of cos pi over 2 squared times cos pi over 2 raised to the power of 3 times etc. cos pi over 2 raised to the power of 10 times sine pi over 2 raised to the power of 10. Now this was asked in JEE Mains 2019. Now on observation, clearly we can see the smallest angle is pi over 2 raised to the power of 10. So let me start by writing the smallest angle. So it's going to be cos pi over 2 raised to the power of 10 followed by cos pi over 2 raised to the power of 9 times cos pi over 2 raised to the power of 8 up unto cos pi over 2 raised to the power of 2 times sine of pi over 2 raised to the power of 10. Now clearly you can see if you were to double this, you would get this term. If you were to double this, you will get the next term. If you were to double this, you will get the succeeding terms. So clearly you can apply the cos series formula, which in this case is going to be, now clearly you can see that the last term is 2 raised to the power of 2, and if you were to start here, it's going to be 2 raised to the power of 10. So you have terms from 2 raised to the power of 10 ending up to 2 raised to the power of 2. So that means you've got 9 terms present here. So hence the formula is going to be sine 2 raised to the power of 9. The smallest angle is pi over 2 raised to the power of 10, and this has to be divided by 2 raised to the power of 9 times sine pi over 2 raised to the power of 10. Now this has to be product multiplied with sine of pi over 2 raised to the power of 10, right? Now clearly sine of pi over 2 raised to the power of 10 can be cancelled, and this can be rewritten as sine of 2 raised to the power of 9 times pi over 2 raised to the power of 10 divided by 2 raised to the power of 9, right? So now you can clearly see 2 raised to the power of 9 and 2 raised to the power of 10. So this is going to give me sine pi over 2 divided by 2 raised to the power of 9. Now what is sine pi over 2? That's going to be 1 divided by 2 raised to the power of 9. So if you were to evaluate 2 raised to the power of 9, that would give us 1 over 512. Expected to evaluate sine 18 degrees. So how are we going to do that? Now foremost, what I wish to do is I would like to let theta be equal to 18 degrees, and then I will multiply it by 5 both sides. So 5 times theta is equal to 5 multiplied with 18. 5 8s are 44, so you get 90 degrees here. Now I wish to write 5 theta as 3 theta positive 2 theta is equal to 90 degrees. So over here, from here, I wish to write, this is theta, right? 3 theta to be equal to 90 negative 2 theta. Now I wish to take cos both sides, right? Taking cos both sides, we would get cos of 3 theta is equal to cos of 90 negative 2 theta. Now you got cos 3 theta. Now cos 3 theta has got a formula, so we can use that formula. So this is going to be 4 times cos cube theta negative 3 times cos theta is equal to cos of 90 negative 2 theta. Now this is a formula, right? So having got this, now we can also apply the formula for cos of 90 negative 2 theta. Now this is going to be, now let me just show you 90 negative 2 theta. So this is 0, this is 90 degrees. So 90 negative means it comes in the first quadrant where all ratios are positive. So this is going to be sine of 2 theta. On the left you got 4 times cos cubed theta negative 3 times cos theta. On the right you got sine 2 theta. By formula sine 2 theta is 2 times sine theta cos theta. So this is 4 times cos cube theta negative 3 times cos theta. Now clearly I can cancel a cos theta and a cos theta. So this would be rewritten as 4 times cos square theta negative 3 is equal to 2 times sine theta. Now I know that cos square theta is 1 negative sine square theta. So if we were to use that, this is going to be 1 negative sine square theta negative 3 is equal to 2 times sine theta. So distributing it, I would get 4 times sine square theta negative 3 is equal to 2 times sine theta, which can be rewritten as 4 negative 3 followed by 4 sine square theta negative 2 times sine theta is equal to 0. This is going to be 1 negative 4 times sine square theta negative 2 times sine theta is equal to 0. If I were to multiply by negative 1, I would get 4 times sine square theta positive 2 times sine theta negative 1 is equal to 0. So this is actually a quadratic equation in sine. So taking a is equal to 4, b is equal to 2 and c is equal to negative 1, I got sine theta to be equal to negative 2 plus or minus root of negative 2, right, negative, so this is actually positive 2 because b is 2, so it's going to be negative 2 plus or minus root of b squared negative 4 times a is 4, c is negative 1 divided by 2 times a is 4. So this is negative 2 plus or minus root of 2 squared is 4, negative negative positive, 4 4s are 16 divided by 2 times 4 is 8. This is equal to negative 2 plus or minus root of 4 added with 16 would give me 20 divided by 8. I can rewrite this as 4 times 5 divided by 8. I can take 4 out, so that's going to be negative 2 plus or minus 2 times root of 5 divided by 8. If I were to take 2 out, negative 1 plus or minus root of 5 divided by 8, which is going to give me negative 1 plus or minus root of 5 divided by 4, right? So therefore you have sine theta is equal to negative 1 plus root 5 divided by 4, or we got sine theta negative 1 negative root 5 divided by 4. But what is theta? But theta is equal to 18 degrees. So this would mean, if I were to substitute 18 degrees, this means sine of 18 degrees is equal to negative 1 plus root 5 divided by 4, or sine 18 degrees is equal to negative 1 negative root 5 divided by 4. So this is a negative value. Now where is 18 degrees? Now this is 0, this is 90. 18 degrees is in the first quadrant where all ratios are positive. So this is not possible. So this would mean, therefore, sine of 18 degrees is equal to root of 5 negative 1 divided by 4, which is a very important result in trigonometry. So I hope you got this question, students. We'll move on to the next one. Wait and get the value for tan 22.5 degrees. So foremost, what I wish to do is I would like to take, let theta be equal to 22.5 degrees. I would like to multiply both sides by 2. So this is going to give me 2 theta, and this is going to give me 45 degrees. Now in terms of radians, I can write 45 degrees as pi over 4. So I got 2 theta is equal to pi over 4. Therefore, the value of theta is going to be pi over 8. So this is a good substitution for theta. Now we know a formula. What is that? Tan of 2 theta is equal to 2 times tan theta divided by 1 negative tan square theta. Right? So how did I get that? Because we know that tan of A positive B is equal to tan A positive tan B divided by 1 negative tan A times tan B. So using this formula, in place of A and B we substitute theta. So this is going to be tan of theta positive theta, right? That's going to be tan 2 theta, and clearly you will have a tan theta here, and adding up these two would give you 2 tan theta divided by 1 negative tan theta times tan theta, which is tan square theta with a negative sign. So having got that, what I wish to do is I would like to substitute theta to be equal to pi over 8. Okay, so what happens here? This is going to be tan of 2 times pi over 8 is equal to 2 times tan pi over 8 divided by 1 negative tan squared of pi over 8. Now 2 divides 8 4 times. So this is going to be tan pi over 4 is equal to 2 times tan pi over 8 over 1 negative tan squared pi over 8. This is 1. So we have 1 is equal to 2 times tan pi over 8 divided by 1 negative tan squared pi over 8. So you cross multiply. If you cross multiply, you would get this to be as 1 negative tan squared pi over 8. So I would like to rewrite this as 1 negative tan squared pi over 8 is equal to 2 times tan pi over 8. So moving everything to the left hand side, this will give me 1 negative tan squared pi over 8 negative 2 times tan pi over 8 is equal to 0. If I were to multiply by negative 1, this is going to be negative 1 positive tan squared pi over 8 positive 2 times tan pi over 8 is equal to 0. If I were to rewrite this, this is going to be tan squared pi over 8 positive 2 times tan pi over 8 negative 1 is equal to 0. This is a quadratic in tan. So if I were to take A is equal to 1 and B is equal to 2 and C is equal to negative 1, we would have negative 2 plus or minus root of 2 squared negative 4 times A times C times 2 times A, which is negative 2 plus or minus root of 2 squared is 4, negative negative positive 4 divided by 2, which is equal to negative 2 plus or minus root of 8 divided by 2, negative 2 plus or minus 8. I'm going to write it as 4 times 2 divided by 2. When I take 4 out, it's going to be negative 2 plus or minus 2 times root 2 divided by 2 gets cancelled, giving me negative 1 plus or minus root of 2. So you can very well, in place of 22.5 degrees, you can also take pi over 8. It's okay. So let me just write this down. Tan pi over 8 is equal to negative 1 plus root 2, and in this case tan 22.5, which is also tan pi over 8, so it's going to be negative 1 negative root 2, right? So this is what you've got. Now clearly you can see that if you were to take pi over 8 is nothing but 22.5 degrees, so that is actually present in the first quadrant, right? So in the first quadrant, all ratios are positive. Okay, so that would mean this is not possible. Tan 22.5 cannot get a negative value owing to the fact that it is present in the first quadrant. So this would mean our tan pi over 8 is root of 2 negative 1, or tan 22.5 degrees is equal to root of 2 negative 1. So this is the solution for this question, students, and I hope you enjoyed this question. Welcome, students. In this class we will be learning conditional identities. Now I will be giving you a list of identities that are of critical importance in solving questions. So foremost, if a plus b plus c is equal to pi, then we got the following identities to be true. Number 1, sine 2a positive sine 2b positive sine 2c is equal to 4 times sine a times sine b times sine c. Number 2, cos 2a plus cos 2b plus cos 2c is equal to negative 1 negative 4 times cos a cos b cos c. Number 3, sine a plus sine b plus sine c is equal to 4 times cos of a over 2 times cos of b over 2 times cos of c over 2. Number 4, cos a plus cos b plus cos c is equal to 1 positive 4 times sine of a over 2 times sine of b over 2 times sine of c over 2. Number 5, tan a plus tan b plus tan c is equal to tan a times tan b times tan c. Number 6, tan of a over 2 times tan of b over 2 positive tan c over 2 times tan b over 2 positive tan c over 2 times tan a over 2 is equal to 1. So we got 6 conditional identities, and we will start off by proving them. It is imperative that you take note of this, practice them, and make sure that you write them in the corner of your mind. So foremost, students, I'm going to show you the proof for sine 2a positive sine 2b positive sine 2c is equal to 4 times sine a sine b sine c. So foremost, let me consider the left hand side. So I got sine 2a positive sine 2b positive sine 2c. Now if you were to actually consider this to be a c and consider this as d, we can use this formula. We know that sine c positive sine d is equal to 2 times sine of c positive d divided by 2 times cos of c negative d divided by 2. We have already studied this formula. So by using this formula, this can be rewritten as 2 times. This is going to be sine of 2a positive 2b divided by 2 times cos of 2a negative 2b divided by 2 positive sine 2c. So we got that component. So what I wish to do is, now let me just perform some simplifications. So this is equal to 2 times of, I can take 2 out, so this is going to be sine of a positive, because the 2 and this 2 can be cancelled, times cos of a negative b positive sine to c. I'm going to write it as 2 times sine c times cos c. So this is going to be 2 times of sine. Now we know that a positive b positive c is equal to pi, so therefore a positive b is equal to pi negative c. So I'm going to rewrite this as, in place of a positive b, I'm going to write it as pi negative c times cos of a negative b positive 2 times sine c times cos c. So this is actually sine c, right? Of course there's going to be the 2 there because of the 2 being present, but is it plus or minus? That's important. This is 0, this is 90, this is 180, this is 270, and this is 360. Negative means over here, that means sine is positive, so this is going to be plus times cos of a negative b positive 2 times sine c times cos c. So what I wish to do, I would like to take 2 times sine c to be a common factor. So that would mean I now have 2 times sine c of cos of a negative b positive cos c. So this is what I've got. Now we know that a positive b positive c is equal to pi. So that means c is equal to pi negative of a positive b, right? I can always write it like this. So this is equal to 2 times sine c of cos of a negative b plus cos of c is pi negative a positive b. So this is what I've got. Now this is rewritten as 2 times sine c of cos of a negative b. This is going to be cos of a positive b, but it's 180 minus. 180 minus means it's over here. Sine alone is positive, cosine is negative, so you have a negative sign. We have got this 2 times sine c of cos of a minus b followed by a negative sign cos of a positive b, right? Now we have a formula which is as follows: cos c negative cos t is equal to negative 2 times sine of c positive d divided by 2 times sine of c negative d divided by 2. So if I were to use this formula, this can be rewritten as 2 times sine c of negative 2 times sine of first quantity c a negative b added with a positive b divided by 2 times sine of a negative b negative of a positive b divided by 2. This is equal to 2 times sine c of negative 2 times negative b positive b gets cancelled, giving me sine of 2a over 2 times, now positive a negative a gets cancelled, giving me sine of negative 2b divided by 2. This is equal to negative 2 times sine c times 2 and 2 can be cancelled, giving me sine a times, sine is a odd function, so the negative can be pulled out, making this as positive. 2 and 2 can be cancelled, giving us sine b. So if I were to rewrite this, this is going to be, already there is a 2 there, so we need to have a 2 squared there. So it's going to be 2 squared times sine a times sine b times sine c, which is nothing but 4 times sine a sine b sine c, which is nothing but the right hand side. Hence the result is proved, right? So I hope you got this question, students. We'll move on to the next one. Students, there are 3 other identities. that would follow the first identity which I've just proved here. So I would want you all to attempt the proof for that. If you got any issues, you can contact me. And now we would prove tan A positive, tan B positive, tan C is equal to tan A times tan B times tan C. So this is the next conditional identity, and we will make an attempt to prove this. So let us consider the left hand side, which is tan A positive, tan B positive, tan C. Now what I wish to do is, instead of saying consider left hand side, I would like to use the following. So let us use the following formula. What is that? We know a formula which is tan of A positive B positive C is equal to tan A positive tan B positive tan C negative tan A times tan B times tan C divided by 1 negative sigma tan A tan B. Now we have already looked into this formula in the previous sections. Now using this, clearly we know that A positive B positive C is equal to pi. So this would mean, if I were to take this as 2, therefore I can rewrite 2 to be as tan pi is equal to tan A plus tan B plus tan C negative tan A tan B times tan C divided by 1 negative sigma tan A times tan B. But what is tan 180? Tan 180 is equal to 0, right? So this would mean I got 0 is equal to tan A plus tan B plus tan C negative tan A times tan B times tan C. So if I were to move this to the left, this would mean I now have tan A plus tan B plus tan C is equal to tan A times tan B times tan C, hence the proof. Right? So that is a lovely proof. So moving on, students, I would like to show you the proof for this particular conditional identity, which is featuring as number 6. Now for this, let us start off with the formula. Now we know this formula, right? We know that tan of A positive B positive C is equal to tan A positive tan B positive tan C negative tan A tan B tan C divided by 1 negative sigma tan A tan B. Right? This is the formula we have used in the previous case. Now instead of A, B and C, we will now use A over 2, B over 2 and C over 2. So this means tan of A over 2 positive B over 2 positive C over 2 is equal to tan A over 2 plus tan B over 2 plus tan C over 2 negative tan A over 2 tan B over 2 tan C over 2 divided by 1 negative sigma tan A tan B. So that's nothing but tan A over 2 times tan B over 2 positive tan B over 2 tan C over 2 positive tan C over 2 times tan A over 2. So this is what we have got. I've just expanded this because it's sigma tan A tan B. Now the reason I expanded this because we will have to show this is equal to 1. Okay, so now I'm going to rewrite, or I should say simplify A over 2 positive B over 2 positive C over 2 This is 2, right? As if I were to take 2 as LCM, this is going to be A positive, B positive, C is equal to the right hand side. Let me write that down. Tan A over 2 plus tan B over 2 plus tan C over 2 negative tan A over 2 times tan B over 2 times tan C over 2 divided by 1 negative tan A over 2 times tan B over 2 times tan B over 2 times tan C over 2 positive tan C over 2 times tan A over 2, right? Now, since A plus B plus C is equal to pi, this would mean A plus B plus C divided by 2 is equal to pi over 2. So, this is pi over 2, but tan pi over 2 is undefined, right? Because it's sine 90 over cos 90. And sine 90 is 1, cos 90 is 0. So it's 1 over 0. So it becomes undefined. So tan pi over 2 is actually undefined. Now the question is, if this left hand side is undefined, when is it possible? Left hand side is resulting in being undefined. So that would mean the denominator, this would mean the denominator should be equal to 0, right? And that means 1 negative of tan A over 2 times tan B over 2 plus tan B over 2 times tan C over 2 plus tan C over 2 times tan A over 2 is equal to 0, right? So that would mean, if I were to push this to the other side, this would mean tan A over 2 times tan B over 2 plus tan B over 2 times tan C over 2 plus tan C over 2 times tan A over 2 is equal to 1, right? Hence proved, right? This is the proof of the result. Is called a summation of trigonometric series, right? Now foremost, what I wish to give is the formula, right? So the first formula would be involving sine. So that's going to be sine alpha positive sine of alpha positive beta positive sine of alpha positive 2 beta plus etc. plus sine of alpha positive n negative 1 times beta is equal to sine of n times beta over 2 divided by sine of beta over 2 times sine of alpha positive n negative 1 times beta over 2. So this is the formula involving sine. So clearly in this case alpha is the first term and beta is the common difference, n is the number of terms. Okay, now before we could head on to do the related questions, there is also an equivalent formula for the cosine series, and that is given as follows: cos alpha positive cos of alpha positive beta positive cos of alpha positive 2 beta plus etc. cos of alpha positive n negative 1 times beta is equal to sine, okay, n times beta over 2 divided by sine of beta over 2. But in this case, instead of sine, you will have cos of alpha positive n negative 1 times beta over 2. Now this is the cosine series and this is the sine series, so the related terms are present here. So now what we will do is we will do some questions. As usual, alpha is the first term, just to be consistent. Let me place them. And beta is the common difference, and n indicates the number of terms. Okay. So let us do this question, students. We are expected to find the sum of the series, and we are given cos pi over 11, positive cos 3 pi over 11, positive cos 5 pi over 11, positive cos 7 pi over 11, positive cos 9 pi over 11. So there are a few observations we will have to make and get the value for alpha, beta and n. Foremost, find the number of terms we got. 1, 2, 3, 4, 5. So n is equal to 5. And what is the first angle? Alpha is equal to pi divided by 11. Now we are expected to find the common difference. So beta is the common difference, right? So that's nothing but 3 pi over 11 negative pi over 11, which would give us 2 pi over 11. Obviously, when we talk about common difference, the angles are in AP. So that's why we are looking into the common difference. So have that in mind. Now, the cosine series formula, you can clearly see that the cosine series formula has got beta over 2. Beta over 2, beta over 2. So we have got beta, so therefore beta divided by 2 is equal to 2 pi over 11 divided by 2, which is actually, if I were to flip it, this is 2 pi over 11. If I were to, this is actually 2 over 1. When you flip it, it becomes 1 over 2. 2 gets cancelled, giving you pi over 11. So hence you have calculated beta over 2 to be as pi over 11. So this is exactly what we are going to be using in the formula. So let me write the formula down. We know that, what do we know? Cos of alpha plus cos of alpha positive beta plus etc. cos of alpha plus n minus 1 times beta, right, is equal to sine of n times beta divided by 2 divided by sine beta over 2 times cos of alpha positive n negative 1 times beta over 2. So I'm not much bothered about the left side, right? The left hand side is actually the given problem. So if I were to employ the formula, this is going to be, let me write that down, applying the formula we get. So what do we get when you apply the formula? This is going to be sine of n 5 terms, beta over 2 is nothing but pi over 11 divided by sine of pi over 11, beta over 2 is pi over 11 times cos of the first term alpha, that's nothing but pi over 11, plus n is 5 negative 1, beta is pi over 11. So this is going to be equal to sine 5 pi over 11 divided by sine pi over 11 times cos of, now this is pi over 11 positive 4 pi over 11, which is rewritten as sine 5 pi over 11 times cos 5 pi over 11 divided by sine pi over 11. I multiply by 2 the numerator, I divide by the same quantity. This is nothing but sine of 2a, right? 2 times sine a cos a is going to be sine 2a. So this is going to be sine 2 of 5 pi over 11 divided by 2 times sine pi over 11. This is what we've got. So this is equal to sine 10 pi over 11 divided by 2 times of sine pi over 11. Now I can clearly rewrite this as sine of pi negative. This can be placed as 11 here, so 11 pi, and this is going to be pi, right? 11 times pi is 11 pi, minus pi is going to be 10 pi over 11. So this is 10 pi, right? So clearly I can generate 10 pi with this expression, sine of pi negative pi over 11 divided by 2 times sine of pi over 11. What is this? This is nothing but, let me just draw the quadrant and show you. This is 180 minus, so sine is positive. So that's going to be sine pi over 11 divided by 2 times sine pi over 11. Sine pi over 11, sine pi over 11 gets cancelled, giving me 1 over 2, which is the solution for this question. So now we are going to look into the summation of cosecant series. Now the formula is as follows: cosecant x positive cosecant 2x positive cosecant 4x plus etc. plus cosecant 2 raised to the power of n times x is equal to cot of x over 2 negative cot of 2 raised to the power of n times x. So this is the outcome. Now there are a few things you have to know. The angles in this cosecant series are in geometric progression, and the total number of terms, though it ends with 2 raised to the power of n, the number of terms you can see here to be as n positive 1. Foremost, what we will do is we will start off by considering cosecant x. So we know that cosecant x is equal to 1 over sine x. Now what I will do is I will multiply the numerator by sine x over 2 and also the denominator by sine x over 2. So this is going to be sine x times sine x over 2. So this is what I've got. Now I'm going to rewrite the sine of x over 2 as sine of x negative x over 2 divided by sine x times sine x over 2, right? So what have we done? We started with cosecant x. We know that cosecant x is equal to 1 over sine x, and then I'm multiplying the numerator by sine of x over 2 and also the denominator by sine of x over 2. So we got sine x over 2 divided by sine x times sine x over 2. Now I would like to rewrite the numerator sine x over 2 as sine of x negative x over 2. Fair enough, right? Now we know a formula. What is the formula? We know that sine of a negative b is equal to sine a cos b negative cos a sine b, right? So we would use this formula. If we were to use this formula, this is going to be equal to sine x times cos x over 2 negative cos x divided by sine x over 2 divided by sine x times sine x over 2. Now I can rewrite this as sine x cos x over 2 divided by sine x times sine x over 2 negative, this is cos x, right? Negative cos x times sine x over 2 divided by sine x times sine x over 2. Now sine x cancels, sine x over 2 cancels, giving me cos x over 2 over sine x over 2 followed by cos x over sine x. Now this is nothing but cot x over 2 negative cot x. So if you were to observe this, we started with cosecant x and then we landed up with cot x divided by 2 negative cot x. Now similarly, if we were to move up in obtaining cosecant 2x, we would achieve, actually over here the angle is divided by 2. So similarly for cosecant 2x, we will actually cot, this is actually cot 2x divided by 2, that's going to be x, followed by negative cot 2x. Now moving on, this is going to be cosecant 4x. So in cosecant 4x, the angle has to be divided by 2, so we would get cot 2x negative cot 4x. Again moving on, this is going to be cosecant, this is going to be 8x, and because we started with the cosecant of 2 raised to the power of 0, and this is 2 raised to the power of 1, this is 2 raised to the power of 2, this is 2 raised to the power of 3, so that's why it's going to be cosecant 8x. So this is going to be cot, dividing 8x by 2, we would get cot 4x negative cot 8x. So as we move up, we would finally end up with the cosecant of 2 raised to the power of n times x. So this is going to be equal to cot of, we have to divide this by 2. So if you were to divide this by 2, this would be cot of 2 raised to the power of n negative 1 times x, followed by cot 2 raised to the power of n times x. So this is what we have got. Now clearly you can see that the cot x with a negative sign will be cancelled with the cot x with a positive sign. Cot x with a negative, cot of 2x with a negative sign will be cancelled with cot 2x. Negative cot 4x will be cancelled with positive cot 4x, and so on and so forth. Finally, all of this will be cancelled, leaving us with this term, cot of x over 2, and negative cot of 2 raised to the power of n times x. And this is exactly the result, right? This is equal to the right hand side, hence the result is proved, right? So that is the proof for this cosecant x series. Students, we will move on. Students, we are given a beautiful question. We are expected to find the value of sigma 1 over sine of pi over 4 positive k negative 1 times pi divided by 6 times sine of pi over 4 positive k pi over 6. So this is the term, and value of k varies from 1 to 13, and we are given a list of options. We are given choices as choice A 3 negative root of 3, choice B 2 times of 3 negative root of 3, choice C 2 times of root of 3 negative 1, choice D is 2 times of 2 negative root 3. And this occurred in JEE Advanced 2016. Right. Now, foremost, before I could solve this question, what I wish to do is I would like to draw attention to the previous question, how exactly I started off. It was a proof. I considered cosecant x, which I know to be as sine x. Then I multiplied the numerator by sine of x over 2 and divided by sine of x over 2. I rewrote the numerator as sine of x negative x over 2, and the denominator actually is, in this case, is sine x times sine x over 2. Now if you were to draw your observation to the numerator, clearly you can see that the numerator's angle is actually the larger angle minus the smaller angle. That's exactly what I placed here. That idea is what I'm going to follow in solving this question. Now clearly you can see that the larger angle is this. So let me just take the larger angle, pi over 4 positive k pi over 6 minus the smaller angle, which is pi over 4 positive k negative 1 divided by 6. Of course, there is a pi there. Now clearly you can see pi over 4 can be cancelled. K pi over 6 and k pi over 6 would be cancelled. So giving me positive pi over 6. So to start off, what I wish to do is I would like to multiply by sine pi over 6 and divide by sine pi over 6 times the term sine of pi over 4 positive k negative 1 over 6 times pi times sine of pi over 4 positive k pi over 6. Now this numerator is rewritten in a similar fashion how I just did. I have to take the difference of the larger angle minus the smaller angle. So this is naturally equal to sine of the larger angle is pi over 4 positive k pi over 6, okay, minus pi over 4 positive k negative 1 divided by 6 times pi. Okay, so this is actually sine of this angle divided by, now sine pi over 6, that's nothing but sine 30. Now what is sine 30? Sine 30 is 1 over 2, so I will place 1 over 2 there, times this quantity, which is sine of pi over 4 positive k negative 1 times pi divided by 6 times sine of pi over 4 positive k pi over 6. So this is what I've got. Now what I wish to do is I would like to take, let pi over 4 positive k pi over 6 be equal to A and pi over 4 positive k negative 1 of pi over 6 be equal to B. Just to reduce the complexity of these angles when we are writing them again and again, right? So this is going to be equal to, I can flip this to 1 over 2, that will become 2 times sine of A negative B divided by sine, this is going to be sine B, right? Sine B times sine A, sine B times sine A, yeah, okay, that's fine, sine A. Now I wish to expand this. This is going to be 2 times of, I'm using the formula, so this is going to be sine A cos B negative cos A sine B divided by sine B times sine A. I can further rewrite this as 2 times of sine A cos B divided by sine B sine A negative cos A sine B divided by sine B sine A. Now I can cancel sine A sine A, I can cancel sine B sine B, giving me 2 times of cos B divided by sine B negative cos A divided by sine A. This is what I have got. So this is rewritten as 2 times of cos B over sine B, that's going to be cot B, negative cos A over sine A, that's going to be cot A. Now it's time to revert the angles back. So in place of A, I will have to substitute pi over 4 positive k pi over 6. So this is going to be equal to 2 times of, in place of B, it's going to be cot of pi over 4 positive k negative 1 times pi divided by 6. This is for B, followed by negative cot of A is pi over 4 positive k pi over 6. Now we are being given the summation to be from k is equal to 1 to 13. So we will have to cater to those values. So when k is equal to 1, we have got 2 times of cot of pi over 4. K is equal to 1, this will be 0. So cot pi over 4 negative k is equal to 1, this is going to be cot of pi over 4 positive pi over 6. This is what I've got. Now followed by a positive sign and k is equal to 2. So it's going to be 2 times of k is equal to 2. I would get cot of pi over 4. K is equal to 2 means this is going to be 2 negative 1. That's going to be 1. So I get a pi over 6 negative cot of pi over 4. K is equal to 2. So positive 2 pi over 6. I'm not going to simplify it. I'm just going to write it as it is. Now k is equal to 3 plus 2 times of cot. So 3 means this is going to be pi over 4 positive 2 pi over 6 followed by negative cot of pi over 4. K is equal to 3. So 3 pi over 6. Now finally k is equal to 13. So it's going to be etc plus 2 times of k is equal to 13. Let me substitute 13 here. So this is going to be cot of pi over 4 positive 12 pi over 6 negative cot of pi over 4 positive 13 pi over 6. So this is what I've got. Now clearly you can see that this term and this term gets cancelled, this and this will get cancelled, this and this gets cancelled, this and this will get cancelled, giving me 2 times of cot pi over 4 negative cot pi over 4 positive 13 pi over 6. This is what I've got. Now this is equal to 2 times cot pi over 4. That's going to be 45 degrees, right? And we can simplify that. Now before we can simplify that, let me write that down. Let me simplify this. So this is going to be cot of, now if I were to take 12 as the LCM, this is going to be 3 pi positive 2. That's going to be 6 times 2 is 12, so 26 pi. So I get a 26 pi there already. So that would mean I now have 29 pi. So this is equal to 2 times of cot pi over 4 negative cot 29 pi over 12. This is what I've got. Now I need to perform the simplification. Now this can be further rewritten as 2 of. Now I would like to replace the values now. Now cot of pi over 4, that's 45, that's going to be 1 negative. Now this is going to be rewritten as, this is 29 pi over 12. So I would like to rewrite this as 5 pi over 12 positive. If I were to place a 2 pi here, I think that would be the right choice, because 2 pi times 12 would give me 24 pi plus 5 pi. That would give me 29 pi. So that's the ideal choice. So this is 2 times of 1 negative. Now cot of 2 pi positive 5 pi over 12. So that's nothing but cot of 5 pi over 12. Now cot of 5 pi over 12 is nothing but 1 negative cot 75 degrees, right? Now I can rewrite cot 75 degree. Let me just show you how to find the value of cot 75. I'm going to use cot 75 degree as 1 over tan 75, which is nothing but 1 over tan 30 degree positive 45 degree. So let me just find out the value of 30 degree positive 45 degree, which is nothing but tan A positive tan B divided by 1 negative tan A tan B. Okay, now tan of 30 degrees, so let me just work it out here. Now tan 30 is nothing but sine 30 by cos 30. Sine 30 is 1 over 2, cos 30 is root 3 over 2. So tan 30 is 1 over root 3. Okay, so this is going to be 1 over root 3 positive 1 divided by 1 negative 1 over root 3 times 1, which is nothing but 1 positive root 3 divided by root 3. This is going to be root 3 minus 1 divided by root 3. I can rewrite this by cancelling the terms, and I will get 1 positive root 3 divided by root 3 negative 1. Now this is nothing but tan 75. Okay, so therefore cot 75 is nothing but 1 over tan 75, which we have found out to be as 1 positive root 3 divided by root 3 negative 1. If I were to flip it, I would get root 3 minus 1 divided by 1 positive root 3. So take this value and substitute it there. That's exactly what I'm going to do. So this would mean this is equal to 2 times of 1 negative of root 3 minus 1 divided by 1 positive root 3. So this is equal to 2 times of 1 positive root 3, right, negative root 3, negative positive 1 divided by 1 positive root 3. So root 3 gets cancelled, giving me 2 there. So let me write that down. So I got a 2 of 2 over 1 positive root 3. Now if I were to multiply the numerator and the denominator by 1 negative root 3 divided by, I am multiplying the numerator and the denominator by 1 negative root 3. So this would give me 2 times of 2 times 1 negative root 3 divided by, this is a plus b times a negative b. So that's going to be 1 negative root of 3 squared, right, 3 for me, and this is equal to 2 times of 1 negative root 3 divided by negative 2. So 2 gets cancelled. I have a negative sign here. So what I wish to do is I can clearly take the negative sign out. If I were to take the negative sign out, that would become root 3 negative 1. I have a negative 1 here, so that would become positive. So subsequently I will have a solution as 2 times of root of 3 negative 1, which is a good place for us to wrap up this study on trigonometry. So this is the solution, students. So therefore the choice is going to be this. This is going to be the choice. Okay, this is going to be the choice. 2 times of root 3 negative 1. Thank you, students. Enjoy your night. So that's the conclusion for this topic. Students, having completed the study on trigonometry, let us do some previous year JEE questions. So foremost, let us start with this question, JEE 2010. The question is as follows. The question wants us to find the number of values of theta present in the interval negative pi over 2 comma pi over 2 such that theta is not equal to n pi over 5 for n equal to 0 plus or minus 1 plus or minus 2, and that tan theta should be equal to cot 5 theta and sin 2 theta should be equal to cos 4 theta. So I hope the question is self-explanatory. We are expected to find the values of theta in this interval such that the given equations are satisfied. So foremost, what I would do is I would like to take the information sin 2 theta is equal to cos 4 theta. I know a formula where cos 2 theta is written as 1 negative. Let me write that. Now cos 2 theta is equal to 1 negative 2 times sin square theta. So if I were to use this formula, I can clearly rewrite this as 1 negative 2 times sin squared 2 theta. Now on the left hand side I got sin 2 theta. So now what I wish to do is I would like to bring this negative 2 times sin squared 2 theta on the left hand side. So that would give us 2 times sin squared 2 theta positive sin 2 theta negative 1 is equal to 0. Now this is a quadratic in sin 2 theta. So taking a is equal to 2, b is equal to 1 and c is equal to negative 1. Therefore we can have sin 2 theta is equal to negative b plus or minus root of b squared negative 4 times a times c divided by 2 times a. So this is equal to negative 1 plus or minus root of 1. This is positive 4 times 2 is 8 divided by 4 is equal to negative 1 plus or minus root of 9 divided by 4, which is negative 1 plus or minus root of 9 is 3 divided by 4. So we got sin 2 theta to be equal to negative 1 negative 3 divided by 4, which is nothing but negative 1. This is one particular case. The other particular value is sin 2 theta is equal to negative 1 positive 3 divided by 4, which is nothing but 2 divided by 4, which is nothing but 1 over 2. Right, so from here I get sin 2 theta is equal to negative 1, and then I got sin 2 theta is equal to 1 over 2. Right, now clearly you can see if I were to take the values, now if sin 2 theta is equal to negative 1, then clearly the values for theta is going to be negative pi over 4. That is one particular case. Now the other case is 1 over 2. Now clearly if I were to take equal to pi over 12, I would obtain 1 over 2. So that's the second value. Now the next value would be 5 pi over 12, right? That would also produce 1 over 2. Now I can clearly show you how is that. Now in fact theta is equal to 5 pi over 12, right? So if I were to substitute 5 pi over 12, this is going to be sine 5 pi over 6. Now I can write sine 5 pi over 6 as sine pi negative. So this is going to be pi over 6, right? So 6 pi negative pi divided by 6 would give me sine 5 pi over 6. Now clearly this outcome is going to be sine pi over 6, right? Because I already explained to you what happens when we have sine of pi negative theta. Of course, it all depends what the sign takes here. Now clearly if you were to go and examine the quadrant, this is 0, 90, 180. Sine pi negative is in the second quadrant, sine is positive. So this is nothing but sine of 30, right? So what is sine 30? Sine 30 is nothing but 1 over 2. So clearly we need to produce 1 over 2. The other 1 over 2 is produced by 5 pi over 12. Now this is because we got only 3 values of theta. The reason theta being given in this fashion, right? Now clearly you can see that also if you were to take tan theta is equal to cot phi theta, all 3 values, okay, all 3 obtained values of theta satisfy the given equation. Therefore, the number of values of theta is going to be 3, right? So that is because if that would be the choice, if they are asking us find the number of values of theta for which the 2 equations given are said to be true, then this would be the solution. So this is a previous year 2010 JEE question. Students, so we will move on to do the next one. Students, let's do JEE Advanced 2022 question. So this has been the question that appeared. So let me write that question down. Let alpha and beta be real numbers such that negative pi over 4 less than beta less than 0 less than alpha less than positive pi over 4. If sine of alpha positive beta is equal to 13 and cos of alpha negative beta is equal to 2 over 3, we are expected to find the greatest integer less than or equal to sine alpha divided by cos beta positive cos beta over sine alpha positive cos alpha over sine beta positive sine beta over cos alpha raised to the power of 2 is what? So that's the question. Now the question looks a little bit challenging, but actually it isn't, right? So we can easily obtain the solution for this question in the following fashion. So foremost, what I will do is I will just take the given information. Let sum j or capital J be equal to sine alpha divided by cos beta positive cos beta divided by sine alpha positive cos alpha divided by sine beta positive sine beta divided by cos alpha. This is what has been given. I'm not taking the square. I would have to manipulate this first with what else we have been given, with sine of alpha positive beta is equal to 1 over 3. Actually this is 1 over 3, right? 1 divided by 3, and cos of alpha negative beta is equal to 2 over 3. I moved on to a new page due to lack of space. Now what I wish to do is I would like to club the following in this fashion. So sine alpha, the first term, I'm taking the first term and I'm actually clubbing it with the third term. So that's going to be cos alpha over sine beta, and then writing the rest of the terms as it is. So cos beta divided by sine alpha positive sine beta divided by cos alpha. Now I can take the LCM for this. The LCM is cos beta times sine beta. If you were to take that, cos beta will get cancelled, giving me sine alpha times sine beta positive. In this case, sine beta gets cancelled, giving me cos alpha cos beta, followed by, let me take the LCM as sine alpha cos alpha. This would give me cos beta cos alpha. Positive cos alpha gets cancelled, giving me sine alpha and sine beta. So this is what we've got. So what I wish to do is, I would like to, what is this? This is nothing but cos alpha cos beta, positive sine alpha sine beta. So I can write this as cos of alpha negative beta divided by, I'm going to write this as sine beta times cos beta positive. This is actually cos of alpha negative beta divided by sine alpha cos alpha. So cos of alpha negative beta, cos of alpha negative beta can be taken out. So this would mean I now have cos of alpha negative beta of 1 over sine beta cos beta positive 1 over sine alpha cos alpha. So this is what I've got. Now what I wish to do is, I would like to multiply the numerator by 2 and divide it by 2. So you got a 2 there, and I will also multiply by 2 and divide by 2. So this is equal to cos of alpha negative beta of 2 over, now 2 times sine beta cos beta, what is that? That is nothing but sine 2 beta positive 2 over, now 2 times sine alpha cos alpha, what is that? That's nothing but sine 2 alpha. So this is what we've got. I can take 2 out, so this is going to be 2 times of cos of alpha negative beta. Now we have got a value, right? Now cos of, let me write that down. We are given, so what are we given? We are given that cos of alpha negative beta is equal to 2 over 3. So substitute that 2 over 3 there. So I'm taking 2 out, along with that there is a 2 over 3 because of the fact it is given, right? So it's going to be 1 over sine 2 beta positive 1 over sine 2 alpha. This is what we've got. Now having obtained this, we can actually take the LCM again. So this is going to be 2 to 4 divided by 3 of, if you were to take the LCM as sine 2 alpha sine 2 beta, this is going to be sine 2 alpha positive sine 2 beta. Now I can clearly apply a formula, right? This is actually sine C positive sine D. We have already studied this formula. You can verify that as we have covered it in detail. So if you were to use that formula, this is going to be 2 times of sine of C positive D. So 2 alpha positive 2 beta divided by 2 times cos of 2 alpha negative 2 beta divided by 2, and that has to be divided by sine 2 alpha times sine 2 beta. So let me write that, sine 2 alpha times sine 2 beta. Now I can take 2 out, so 4 times 2 is 8 over 3, and 2 gets cancelled, giving me sine of alpha positive beta times cos of alpha negative beta, because 2 gets cancelled, divided by, now 2 times sine alpha times sine 2 alpha times sine 2 beta, right? Now what I wish to do is, I would like to multiply the quantity in the denominator by 2, because I can use the formula with cos, right? So for that I need to have a 2 there. If I'm multiplying here by 2, I should subsequently have a 2 in the numerator. So let me write that. So 2 times sine 2 alpha times sine 2 beta, I have a 2 there in the numerator. So multiplying by 2, dividing by 2. So this is equal to 16 divided by, now don't multiply this 2 with 3, right? I have deliberately multiplied this so that I can use the formula. So 16 over 3 of sine of alpha positive beta times cos of alpha negative beta. So now it's sine, so we can use the cosine formula. So that would be cos of C minus D. So it's going to be cos of 2 alpha minus 2 beta. right, followed by negative sine cos of 2 alpha positive 2 beta, right? So that's the formula. So this can be further rewritten. Now I can take 2 out, right? I can take 2 out here. So this is equal to 16 over 3 sine of alpha positive beta times cos of alpha negative beta divided by cos of 2 times of alpha negative beta negative cos of 2 times of alpha positive beta, right? So this is what I've got. Now what I wish to do is I can make the substitution for the numerator. Sine of alpha positive beta, that's going to be 1 over 3, right? So this is 16 over 3 times 1 over 3 times cos of alpha negative beta is 2 over 3, that's fine, divided by, now I will have to get rid of this 2. So how am I going to get rid of this 2? I'm going to use this formula. Cos 2 theta is equal to 2 times cos squared theta negative 1, this formula. Then there is also subsequently another formula. Cos 2 theta is equal to 1 negative 2 times sine squared theta. So these two formulas can be used. So if I were to use these two formulas, this is going to be equal to, so I will write it down here. So 2 times cos squared of, in place of theta, I've got alpha negative beta negative 1, that is one particular quantity. Now followed by the next quantity. The next quantity, there is a negative sign there, so we got to place the negative sign. Now for this cos of 2 alpha positive beta, I'm going to use this formula, right? So this is going to be 1 negative 2 times sine squared of alpha positive beta, right? That's what I am going to do. Simplifying the above term, you get 32 divided by 27 of 1 over 2 times of 4 over 9 negative 2 positive 2 over 9. This is equal to 32 over 27 of 1 over 4 times 2 is 8 over 9 negative 2 positive 2 over 9, right? This is what we've got. So now what I wish to do is I would like to rewrite 32 over 27. I will have to simplify the denominator. So I will club these two together. If I were to club these two together, I would get 10 over 9 negative 2, which is equal to 32 over 27 of 1 over 9 times 2 is 18, 10 negative 18 over 9, which is going to give me 32 over 27 of 1 over 10 negative 18 is negative 8 over 9. If I were to flip it, I will get 32 over 27 of 9 over 8 with a negative sign. 9 divides here 3 times. 8 times 4 is 32. So you get negative 4 divided by 3. Now this is my j, but we are expected to obtain j squared. So j squared is negative 4 over 3 raised to the power of 2, which is 16 over 9. You divide it, you get 1.77. But we are expected to find the greatest integer function, right? So this is what we need. And what is the greatest integer value for 1.77? It's nothing but 1. And this is the answer for this question. So probably I can write that to be the solution. So that is the end of the solution for this 2022 JEE advanced question, students. I hope we have covered quite a bit in this particular topic on trigonometry, and that would complete this section. Thank you.